If you're preparing for your algebra final exam, then I know how overwhelming it can feel to not know what it is that you're supposed to study. So in this video, I've put together over 3 hours and over 45 example problems to help you prepare for your algebra final exam. So without further ado, let's get started with problem 1. So here's the first problem, the first important concept. And for this one, we need to solve for x in this inequality. So before we can even deal with this less than sign, we first need to solve for x. And the way that we do that is by getting x by itself. Now, x is trapped inside of this little set of parentheses, but whenever you see this pattern here, where you have a number in front of this set of parentheses, this should immediately say in your head, this is the distributive property. So remember that because there's no sign here, this is multiplication. And what the distributive property says is that when you have a number in front, you have to multiply the number to all of the parts of the parentheses. In this case, there's 2 parts. So we need to multiply -2 times 3x, and we need to multiply -2 times -1. So -2 times 3x, well, 2 times 3 is 6. And then we have 1 minus sign, so the minus sign stays. And then the x is going to stay as well. And then here we have -2 times -1. 2 times 1 is 2. And then 2 negatives make a positive. So this is going to be +2. And then on the right side, we're going to leave everything else the same. The sign's going to stay the same, and the 8 is going to stay the same. So now we've got an x unstuck. It's not trapped inside of parentheses anymore, but we still have to get x by itself. So we need to get rid of this 2 on this side and this -6. I'm going to get rid of the +2 because you should always do addition and subtraction before you do multiplication and division. So the opposite of addition is subtraction. So to cancel out the +2, I'm going to do -2 on both sides. So the +2 and -2 cancel out. On the left side, we just have -6x. And on the right side, we have 8 minus 2, which is 6. And now we just have a one-step algebra problem. And remember, like I said before, whenever you don't have a sign, that means multiplication. So this -6 is being multiplied to x. So to get rid of the -6, we need to do the opposite of multiplication, which is division, and divide both sides by -6. So the -6's cancel out. On the left side, we just have x now. And on the right side, we have 6 divided by 6 is 1. And we have 1 minus sign, so the minus sign stays. Now notice how I'm avoiding writing this inequality sign right now. And that's because we've just triggered a special rule. So whenever you multiply or divide by a negative number, and you have a less than or greater than sign, then you need to flip that sign. So because we divided by a negative number, -6, less than is now going to become greater than, which means our final answer is x is greater than -1. So here's the second problem that we'll be doing, and for this one, we've got a graph. We've got a line on the graph, and we have to write the equation of that line. So there are many different ways that you can write the equation of a line, like different forms, like point-slope form or standard form. But whenever you're writing the equation of a line like this, the most important form you need to know is slope-intercept form. And you've probably heard of this equation before. Slope-intercept form is y equals mx plus b. Every equation of a line can be written in this way. So for example, the equation of a line could be y equals 2x plus 1. That's in y equals mx plus b. So y and x are always going to stay the same, but we need to figure out what m and b are and replace them with the right numbers. So what does m stand for? Well, m obviously stands for slope. And they didn't do much of a better job with b because b stands for y-intercept. So to figure out the equation of our line, we first have to figure out the slope and the y-intercept. So let's start by figuring out the slope. Slope is equal to rise over run. But what do rise and run actually mean? Well, we just need to pick out 2 points on this line, and then we have to figure out how much it needs to rise and run to get from the first point to the second point. And for picking out 2 points, you can pick any points on the graph, but I recommend you pick points that are in the corners of boxes so that you don't have to deal with fractions. So for example, this point right here is really good because it's right in the corners of all of these boxes, and we won't have to deal with fractions or decimals. And then up this point right here is also going to be good, and all you need is 2 points. So this is what we need to find the slope. So we're going to start at the point on the left, and we're going to figure out how many boxes it needs to rise and run. So to get from this point to this point, it needs to rise or go up 2 squares. So because it needs to go up 2 squares, the rise is going to be equal to 2. And now what about the run? Running means going to the right. So to get from here to this second point that we drew, we need to run 1, 2, 3 squares. So our run is going to be 3. Now, if this was a fraction that you could simplify, like 4 over 2, that would just be equal to 2, then you would do that. But in this case, we can't simplify this fraction. 2 over 3 just can't be simplified. So in this equation, we're going to replace m with 2 over 3. So now we just need to figure out the y-intercept, or b. And the y-intercept is easier than the slope. The y-intercept is just wherever the graph crosses the y-axis. The y-axis is this big up and down line here, this one left and right, that's called the x-axis. And it looks like it crosses the y-axis right here. So b is going to just be equal to however many boxes up or down this point is, wherever it crosses. And starting from 0, it looks like we need to go down 1, 2 squares. So if we had gone up 2 squares, for example, the y-intercept would be 2. But because we've gone down, those are actually negative numbers. So b is going to be equal to -2. Now this plus minus 2 is kind of redundant. We don't need to have both of those. That's just the same thing as subtracting. So we're going to just turn this into subtraction. It's just -2. So there we go. We've written the equation of this line. Y is equal to 2/3 x minus 2. That's the equation of the line. So here's another problem that involves writing the equation of a line. But this time, all we're given is a point that the line passes and then the slope of the line. So how are we going to write this? Well, eventually we want this to look like y equals mx plus b. That is our eventual goal because that's like the main format for the equation of a line. But whenever you have just one point and the slope, there's actually another format that's going to work really well. And it's creatively named point slope form. So point slope form is y minus y1 equals m times x minus x1. So x and y are going to stay the same, just like before, where we just leave them in the equation. M is equal to the slope, just like before. But y1 and x1 are going to be equal to a point on the graph. So let's go ahead and use point slope form to write the equation of our line. So y is going to stay the same, and that's going to be minus y1, which is the y of a point on the graph. The y of this point is 3, because remember in coordinates, you always have x first and then y. So -2 is x, but 3 is y. So we're going to replace y1 with 3. Now what is m? Remember that m is the slope, and the slope, it says, is equal to 1/2. So we're going to replace m with 1/2. X is going to stay the same, and then x1 is an x of coordinates on the graph. And in this case, x is equal to -2. So we're going to replace x1 with -2. But you may notice here that we have -2, and two negatives make a positive. So these are actually going to become positive, and this is going to become a plus sign. So we now have the equation of a line, but we want to turn this back into slope-intercept form. So let's go ahead and simplify this as much as we can. So right here, you may notice that this is the distributive property. So we need to multiply the 1/2 out to the x and then to the +2. So this left side is going to stay the same for now. And then on this side, we have 1/2 times x. You can't multiply a number and a letter, so it's just going to stay as 1/2 times x. And then we need to multiply the 1/2 to the 2. Now, we could go ahead and write this out. 1/2 times 2 over 1, because remember that a number that's just by itself is the same thing as being over 1. So 1 times 2 is 2, 2 times 1 is 2, and 2 divided by 2 is 1. So 1/2 times 2 is equal to just 1. Or you could have recognized that these are actually opposites. So 1 over 2 is the direct opposite of 2 over 1. So when you multiply them together, you're just going to get 1. So now the last thing to do is to move this into slope-intercept form. And the important thing to know is that in y equals mx plus b, y is by itself. So let's try to get y by itself in this equation. The only thing stopping us is this -3. So I'm going to do the opposite of minus, which is plus, and add 3 to both sides. So the -3 and the +3 are going to cancel out. On the left side, we're just going to have y. And on the right side, we're going to have the 1/2 x. That's just going to stay the same. But then over here, we have +1 plus 3. 1 plus 3 is 4, so that's going to combine into plus 4. And there you go. This is the final equation. This is in slope-intercept form. It's in the same format. Now, I don't know about your algebra class, but when I took algebra, we had to find the domain and range of a graph like 27 times. So how do we find the domain and range of this graph? Well, first of all, what do domain and range mean? Well, domain is basically just all of the numbers that you can put in for x. Or in other words, when we have a graph, what numbers of x does the graph cover? And then range is the same thing, but for y. What values of y could you get out of the graph? Or what numbers for y does the graph cover? So what values of x are possible on this graph? And remember that x is left and right and y is up and down. So for the domain x, well, it looks like we can put in anything we want for x. So like, for example, if we wanted to put in 1 for x, go 1 square to the right, well, that's on the graph. Or if we wanted to go 2 squares to the right, that's also on the graph. See, right here. Now, I know this might seem tricky because what if you wanted to put in 4 for x? And you're like, well, that's not on the graph, right? But remember that this arrow here means that the graph goes infinitely in this direction. And even though this graph is mostly going up, it's always going a little bit to the right. So at some point, you're going to hit x equals 4, and you'll be able to take the whatever y is equal to when you plug in 4. And it's the same thing for negative numbers as well. So if I wanted to plug in -2 for x, that means going 2 squares to the left, then I do hit the graph right here. And it goes infinitely in this direction as well. So eventually it's going to hit every single number for x in this way. So whenever the graph covers literally every single number, we call that all real numbers. Or another way that you might have to write all real numbers is to say that it goes all the way from negative infinity to positive infinity. And the way that you do that is with parentheses. So you'd put it in parentheses and you'd put negative infinity, comma, positive infinity. And this is basically just saying I can put in any number from negative infinity all the way to positive infinity, which means literally any number. Now, what about the range? Can we get any number for y as well? Well, remember that y is up and down. And if we were to just pick any number like 2, 2 is on the graph. See, it's right here. And it's also right here. We actually get 2 numbers for y equals 2. Or if you wanted to plug in 6, for example, 6 is all the way up here. But that actually works as well, because remember, these go infinitely. And you will eventually hit the graph twice as well. But what if you wanted to find out where y is equal to -3, for example? -3 would be 3 squares down, so right here. And you may notice that it does not hit the graph anywhere here. There is nowhere on the graph where y is equal to -3. And the same is true for -4 or -2 or any of these numbers down here. So to find the range, we need to find the smallest number possible for y, because it looks like we can get the numbers to be too small. And the smallest number for y is going to be right here. So how far down is this? Well, starting from 0, we need to go down 1 square. So right here, y is equal to -1. And anywhere lower than -1 is not going to be a possible point on our graph. So we're going to write our range like this. We're going to write y, and then it has to be either -1 or it needs to be bigger than -1. So we're going to use greater than -1. And the other important thing to know is that -1 itself, like exactly -1, is included in the range. We can get exactly -1. So whenever you can get the exact number, you have to put a line underneath the sign, because this means or equal to. So greater than or equal to -1. The other way you can write your range is just like we did before with here. So we can put it in parentheses and say that we're going from -1 all the way up to infinity, because it goes infinitely upward, but not downward. And there's actually one more thing that we have to change here as well, because -1 is included in the answer. So next to -1, instead of parentheses, we're going to have a bracket. And I know it looks kind of weird having a bracket on the left and parentheses on the right, but that's how you do it, because -1 is included in the range, but infinity isn't a number. You can't actually plug in infinity. So that's why we use parentheses for infinity. So the domain is all real numbers, but the range is just y is greater than or equal to -1, because you can't have anything less than that. All right, so here's a problem that's pretty similar to the one that we did at the very start of this video. Except instead of just solving for one letter, we have to solve for two letters, and we have two equations. We wouldn't be able to solve for two letters if we only had one equation. So there are two main methods to solve a system of equations. That's what this is called. And there are substitution and elimination. I personally like elimination better. I think it's faster, but you're free to use whichever one you want. So I'm going to show you what elimination would look like for this problem. The goal of elimination is to add the two equations together. And then when you add them together, you would cancel out one of the letters and leave you with just one letter left. But if we were to add these two equations together right now, that wouldn't happen. Like 3x plus 2x is 5x. And then 2 minus 1, we don't have a number here, so that just means 1. 2 minus 1 is 1. And then 1 minus 4 is negative 3. Like, we haven't accomplished anything, right? We still have x and y. So to solve this, we need to ask ourselves the question of what number would be really convenient to have. So for example, I think it would be really convenient if this number right here was a 2. Because if this number was a 2, then if we were to add these together, we would do all the math, and then plus 2y minus 2y, those would cancel out into 0, and we would just have x. So I've determined that I really want this number to be a 2. So what do I have to do to make this number a 2? Well, I can't just make it a 2. That's not really allowed in algebra. But I can do the rule of algebra that says I can do whatever I want to both sides of an equation, as long as I do it to both sides. So this equation here, I'm going to multiply the entire thing by 2. And by doing that, I'm going to make this number 2, but I'm still obeying the laws of algebra. So this first equation is going to stay exactly the same. But in the second equation, I'm going to multiply everything by 2. So 2 times 2 is 4, so 2x is going to become 4x. Then here we've got minus 2 times y, that's just 2y. And then we have 2 times negative 4. 2 times 4 is 8, and we have one minus sign, so the minus sign stays. And now let's go ahead and try adding these equations together. 3x plus 4x is 7x, and then plus 2y minus 2y, those are going to cancel out to 0, like I said before. And then that's going to be equal to 1 minus 8. Whenever you get confused about negative numbers, just think of it as money. So you earned $1, but then you lost $8. So you're down $7, so minus 7. And now we actually just have a one-step algebra problem to solve. So 7x is the same thing as 7 times x. So I'm going to do the opposite of multiplication, which is division, and divide both sides by 7. So the 7's cancel out. On the left side, I just have x. And on the right side, I have 7 divided by 7 is 1, and 1 minus sign, so the minus sign stays. So x is equal to negative 1. But remember that this is only one part of the problem, because the second part is to solve for y. So I'm going to make a note up here that x is equal to negative 1. So to solve for y, I just need to pick out any one of these equations, plug in negative 1 for x, and then solve for y. I'm going to choose this equation right here because y is closer to being by itself. So I'm going to rewrite this equation, except instead of x, I'm going to write negative 1 because we now know that x is equal to negative 1. And now we just need to solve for y. So this can be simplified here, right? This is 2 times negative 1, that's negative 2. And now to get y by itself on this side of the equation, I need to get rid of this minus 2. So I'm going to do the opposite of minus, which is plus, and add 2 to both sides. So these cancel out. On the left side, I just have, don't make the mistake of just saying we have y. We actually have minus y. The minus signs always have to stay. And that's going to be equal to negative 4 plus 2. So you lost $4, you got 2 back, but you're still down $2. So minus 2. And now here we have negative y equals negative 2. So how do we get rid of this minus sign? Well, how about I just put another minus sign on both sides of the equation? If we just put another minus sign on both sides, then 2 negatives make a positive, 2 negatives make a positive. So I have positive y equals positive 2. And there we go. Y is equal to 2. So our final answer is that x is equal to negative 1 and y is equal to 2. And if you wanted to check your work, you could plug both of those numbers into the equations and make sure that they're true. So this is possibly one of the most important concepts that you'll need to know for your exam, and that is graphing transformations of functions. Basically, if you wanted to graph any sort of equation, you could plug in numbers for x, see what you get for y, and then like plot those points on your graph and then connect them up with a line. But for equations like this, we can actually use a faster method called transformations. And to do that, we need to take a parent graph and then make changes to it. So there are a few main types of parent graphs. Possibly one of the most common is just y equals x. There's also y equals x squared, and also y equals the absolute value of x is another common one. So which one do you think we're going to use here? Well, right here I notice that we have a squared, and I know it's not x squared, it's x minus 1 squared, but the basis for this equation is that we're squaring x. So our parent graph is going to be y equals x squared. So the whole idea behind transformations is we're going to graph y equals x squared, our parent graph. And the more problems you do of this is going to be the same every time. And then all we have to do is figure out what adding this to is doing to the equation, is doing to the graph, and then figure out what this minus 1 is doing, and then just make those changes to our parent graph. So let's start by graphing y equals x squared. What happens if we put in 0 for x? Well, if we put in 0 for x, then for y, we're going to get 0 squared. 0 times 0 is 0. So when x is 0, y is 0. And 0, 0 is right here in the middle of this graph. But now what about if we put in 1 for x? Well, if we put in 1 for x, for y, we're going to get 1 squared. 1 times 1 is 1. So when we put in 1 for x, we get out 1 for y. So to represent that, I'm going to move 1 squared to the right because x is 1. And then because y is 1, I'm going to move 1 square upward. And I'm going to put a point right here. So then what about when x is equal to 2? Well, when x is 2, y is going to be equal to 2 squared. And 2 times 2 is 4. So when x is 2, y is actually equal to 4. So to graph that, we need to go 2 squares to the right because x is 2. And then we need to go 4 squares upward because y is 4, because y is up and down. And we will plot a point right here. Now we have a lot of points on the right side here, but we also need points on the left side. And on the left side, those are negative numbers. So what if we plugged in negative 1 for x? Well, for y, that's going to give us negative 1 squared. And negative 1 times negative 1 is positive 1. Remember that squaring always gives you a positive number because we're multiplying two negatives together. So when x is negative 1, that's 1 squared to the left. Y is going to be positive 1, which is 1 square upward. So we're going to put a point right here. And now what about when x is negative 2? Well, then y is going to be negative 2 times negative 2, negative 2 squared. And that gives you positive 4, because 2 times 2 is 4, and then two negatives make a positive. So when x is negative 2, that's 2 squares to the left. Y is positive 4, so that's 4 squares upward. So I think we have plenty of points here. So the last thing that we need to do to graph our parent graph is to just connect all of these points up. And there you go. We now have our parent graph for y equals x squared. Now, I know that might have seemed like a lot, but remember that every time you graph y equals x squared, it's going to look exactly like this. So just remember that in x squared, a parabola is always going to be this U shape. And just remember that the points are going to be at 1, 1, and then 2, 4, because 1 times 1 and 2 times 2. So now for the transformations part. What is this 2 doing to the graph, and what is this minus 1 doing to the graph? Well, let's look at this minus 1 first here. If this minus 1 or a plus 1, if this was on the outside, then it would move the graph up or down. So if this was a plus 1, it would move the graph up 1 square, or if this was a minus 1, then it would move the graph down 1 square. But because this minus 1 is on the inside of the parentheses here, it's actually going to move the graph left or right. And it's the opposite of what you might think. Negative numbers usually mean to the left. But whenever we're doing transformations, left and right are switched. So negative actually moves the graph to the right, and positive moves it to the left. So because this minus 1 is inside the parentheses, we're going to move the entire graph 1 square over. So this point that was right here is now going to be over here. And then this point over here is now going to be here, and so on. And when we do this to all the points on the graph, we can go ahead and draw our new graph that we have now moved 1 square over. So just to reduce the clutter, I'm actually going to erase our parent graph. And there we go. This is our new graph with the transformation of minus 1. But there's actually one more transformation. What is this 2 doing here, and what is it doing to our graph? Well, remember that from earlier in the video, I talked about how this means multiplication because there's no sign in between. So we're actually going to be multiplying all of the numbers by 2. And in transformations, we call this compressing, and you'll see why it's going to compress the graph. This point right here, this little like vertex, the anchor point, is always just going to stay where it is because that's basically just the same as 0. But this point here, this point is 1 square above the vertex, or you could say it's 1 square above the ground. And because we're multiplying everything by 2, this point that is 1 square above is now going to be 2 squares above. And this point here is also 1 square above our vertex. It's now going to be 2 squares above. Now this point here, this point is 4 squares above our vertex. And now it's actually going to be 8 squares above, which is just off the screen. Like we can't even graph that. So because any other points would just be completely off the screen, this is as good as we can do. So we need to graph our new graph with this point here staying the same, and then these 2 points being like compressed. So I'm going to go ahead and terribly draw our new parabola. So there you go. This is going to be the new parabola. And you can now see why we call it compressing, because multiplying by 2 has actually like shrinked the graph. It's made it like more compressed together. If this was less than 1, if it was like 1/2, it would like expand the graph. So we can go ahead and erase all of our work that we've done before and just leave the final graph. This is the final graph of y equals 2 times x minus 1 squared. So that problem was the last graphing problem of this video, which if you're anything like me, you probably are very happy about that. But now we're going to go over quadratic equations. And for quadratic equations, there are tons of different ways to solve them. So I'm first going to go over how to factor quadratic equations and then how to solve them by completing the square. So how do we solve for x here by factoring? Well, remember that in a quadratic equation, x shows up twice. We have x squared here, and then we just have x. And we can't get x by itself the normal way because there's no way for us to combine these, an x squared and a regular x. So we have to do special methods. So factoring is usually a lot easier when you don't have a number in front of x squared. Like if this was gone, then we could just do the easier method of factoring. But because we have a number in front of x squared, we have to use the x method. So I'm going to go ahead and draw our x right here. So in the top of our x, we're going to multiply this number right here. And remember, the minus signs always stay. So this number here and the number in front of x squared. And when we multiply these together, we get 2 times 6 is 12. And then 1 minus sign, so the minus sign stays. So this number right here is going to be the number that we try to multiply to. And I'll explain that in a minute. But for now, we need to figure out the number that's at the bottom of our x. And that's going to be the number that's in front of x. But there is no number in front of x. But remember, that just means that there's an invisible 1. So at the bottom of our x, we're going to put 1. And this is the number that we're trying to add to. So we need to find 2 numbers that multiply to negative 12 and add to 1. So I'm going to ignore the minus sign for now and find 2 numbers that multiply to 12. Well, the obvious one is 1 times 12. 1 times 12 is 12. But we are multiplying to negative 12, and I know that the negative sign needs to be on the smaller number because we're adding to a positive number. If we were adding to a negative number, then I would put the minus sign on the 12 because that's the bigger number. So when we multiply these together, we get negative 12. But if I was to add them, we would get 12 minus 1, which is 11. And we're just looking for 1. So 11 is way too big. This is out. What about 2 times 6? 2 times 6 is 12, and I'm going to put the minus sign on the smaller number because we're adding to positive 1. If we add these together, we get 6 minus 2, which is 4. That's still not what we're looking for, but it is closer. The only other option we have is 3 times 4. 3 times 4 is 12. I'm going to put the minus sign on the smaller number. And negative 3 plus 4 is the same as 4 minus 3, which is 1. And 1 is the number that we're looking for, right? So our 2 magic numbers are negative 3 and positive 4. So let me go ahead and explain what we're going to do with those numbers. These magic numbers, negative 3 and 4, are going to go on the left and right sides of our x, like this. But those aren't just going to be our final magic numbers because we now need to divide one of them. We need to divide one of these numbers by positive 2 here. And this -3, I wouldn't want to divide this by 2 because that doesn't simplify and we're dealing with fractions. But what if I divided 4 by +2? Well, 4 divided by 2 is 2. So I'm going to go ahead and do that. I think that makes more sense. So our two final magic numbers are -3 and +2. So let's go ahead and put that into a factoring equation. We're going to have two sets of parentheses here, like this, and those are going to be equal to 0. And in the parentheses are going to be our two magic numbers, -3 and +2. Now, if we were doing the easy method of factoring, these would both just be x. But actually, because we're doing the hard method, because we have a 2 in front here, one of these has to be 2x. And the one that we put a 2x on is always the opposite of the one that we divided originally. So we divided this 4 by 2. So because we divided the 4 by 2, the 2x needs to go on the -3. And let me go ahead and explain to you why that is. You may have heard of this thing called FOIL, where it's like first, outer, inner, last. So you multiply the first parts and then the outer parts and so on. That's basically how you would multiply two binomials, to multiply two things in parentheses to get the equation. And if you were to do FOIL on this, you would end up multiplying the 2x by the 2, that's for outer, and 2 times 2 is 4. So you would end up with 4x, which is what we had before we divided. So by putting the 2x on the opposite side as what we divided, we basically multiplied them together and got what we got originally. So this is our final factorization. We have two sets of parentheses and they equal 0. Well, what do we do from here? Well, there's a special property here because we're multiplying these two parentheses together and they equal 0. What happens when you multiply something by 0? Well, it becomes 0. So if this happened to be equal to 0, the whole thing would be 0. Or if this was equal to 0, then we'd be multiplying by 0 and the whole thing is 0. So because this is equal to 0, we can actually split this up into two equations. So I can split this up into 2x minus 3 equals 0 and x plus 2 equals 0. And now I just need to solve for x on each one. So 2x minus 3 equals 0. I'm going to get rid of the minus 3 first by doing the opposite of minus, which is plus. And I'm going to add 3 to both sides. So these cancel out. On the left side, we just have 2x. And on the right side, we have 0 plus 3, which is 3. Now, this is multiplication, right? 2 times x. So I'm going to do the opposite of multiplication, which is division. And divide both sides by 2. So the 2's cancel out. On the left side, we just have x. And on the right side, we have 3 divided by 2. That cannot be simplified. So it's just going to stay as 3 over 2. And this is one of our answers. But we are going to get a second answer from this equation. Whenever you solve quadratic equations, most of the time they're going to have two answers. Not always, but most of the time. So I'm going to get rid of this plus 2 by doing the opposite of plus, which is minus. And I'm going to subtract 2 from both sides. So these cancel out. On the left side, we just have x. And on the right side, we have 0 minus 2. This is 0, isn't doing anything. So this is just going to be minus 2. So we've now found our two answers. X is equal to 3 over 2, and x is equal to minus 2. So here's another example of solving a quadratic equation, but this time we need to use the completing the square method. Well, the goal of completing the square is basically to make a perfect factoring situation. So for example, let's say you were to factor this and you were to get your two sets of parentheses, and they would be x minus 3 times x minus 3, right? They're both exactly the same. Well, if you multiply something by itself, then that's the same thing as squaring. So this is the same thing as x minus 3 squared equals 0. And then this gives you the opportunity to just get rid of the squared by square rooting both sides, because that's the opposite of square. Now, this is not going to give you that perfect factoring situation. I mean, that's pretty rare. But we can actually force it to have that perfect factoring situation. So before we do that, it's just going to make our lives easier if we get rid of this number by itself and move it to the other side. So I'm going to do the opposite of minus, which is plus. I'm going to add 7 to both sides. These cancel out. On the left, we just have x squared plus 6x. And I'm going to leave this space here. You'll see why in a minute. And on the right, we have 0 plus 7, which is 7. So now the reason I left this open space here is because we need to figure out what magic number should go right here that would turn this into that perfect factoring situation. And the way that we do that is by actually using this number. So to find out the magic number, you just need to take the number in front of x, you need to divide it by 2, that gives us 3, and then you need to square that number. So 3 squared is the same as 3 times 3, which is 9. So that's the important thing to remember. You divide by 2, and then you square it. So the magic number is 9, and that means we're going to put plus 9 into this space. But remember that in algebra, you have to do everything to both sides of the equation. So because I'm adding plus 9 here into this side of the equation, I also have to add plus 9 to this side of the equation. And that's going to give us x squared plus 6x plus 9 is equal to 7 plus 9, which is 16. So now we know that we're going to have our perfect factoring situation, and now we just need to factor it. But I know you probably don't want to do that whole factoring process again that we did before. So there's actually a shortcut we can use. You know when we divided by 2 and then we squared it? When you divided by 2, we got 3. This number here is going to be our magic number. So when we factor this, we're going to get x plus 3 squared is equal to 16. It's always going to be the number that we got when we divided by 2. And if you weren't sure of that, you could check your work by doing x plus 3 times x plus 3. You could multiply it out and make sure you get this. So now our final step is to get x by itself. But x is trapped in these parentheses, and we have a squared here. So let's do the opposite of squared, which is square rooting. I'm going to go ahead and square root both sides. So the square root and the square cancel, and on the left, we just have x plus 3. But on the right, we have the square root of 16, but it's actually not just the square root. Whenever you're doing a math equation and you square root both sides, what you're actually doing is plus or minus square rooting. So the square root of 16 is 4, but that's actually plus or minus 4. And by the way, the square root of 16 is 4 because it's 4 times 4 is 16. It's what number do you have to multiply twice to get 16. Now I'm going to move this part up to the top so that we can continue the problem. So this plus or minus means that we have an equation where this is positive 4 and one where this is minus 4. So we're actually going to end up with 2 different equations and 2 different answers, just like the last method that we did. So I'm going to split this up into x plus 3 is equal to positive 4, and x plus 3 is equal to negative 4. And we'll go ahead and solve both of these. So on the left, we have x plus 3 equals 4. I'm going to get rid of the plus 3 by doing minus 3 on both sides. And this is going to leave us with x is equal to 4 minus 3, which is 1. So on this left side, x is equal to 1. Let's go ahead and solve the right side now. We'll get rid of the plus 3 in the same way. We'll do minus 3 on both sides. So these cancel out. On the left side, we have x. And on the right side, we have negative 4 minus 3. So you lost $4 and then you lost another $3. So you're down $7. So negative 7. And there you go. We found out our 2 answers. Our 2 answers to this equation are x equals 1 and x equals negative 7. All right, for this problem, we're going to need to be doing a little bit of simplifying. And by simplifying, I mean we're going to be multiplying these 2 sets of parentheses together because there's no sign in between. So earlier I talked about this method called FOIL, which is where you have, like, for example, x plus 2 times x minus 3. And then you go first, outer, inner, last. But this is a little bit more complicated than that because we have 3 parts in this set of parentheses instead of just 2. So we're going to be doing like a slightly more complicated version of FOIL. And it's actually also a slightly more complicated version of the distributive property, but it's all kind of the same thing. So what we need to do is we need to take this first part here, the 2x, and we need to multiply it out to every part of the other set of parentheses. And then we need to take the 3 and do the same thing. So let's start with the 2x. We need to multiply 2x times x squared. So 2 is the only number here, so that's just going to stay as 2. And then we have x times x squared. Well, remember that x squared is x times x. So this is x times x, and then we're multiplying another x. So that's actually x to the third. Next, we need to multiply the 2x to the minus 4x. And remember, the minus signs always stay. So we have one minus sign. The minus sign is going to stay. 2 times 4 is 8. And then x times x is x squared. Now, what about 2x times positive 2? That's the last part here. 2 times 2 is 4. And then we have 1x, so the x is going to stay. And no minus signs, so that's going to be a plus. So this is our final multiplication for multiplying 2x out to all the parts. But remember, now we have to multiply the 3 out to all the parts. So let's go ahead and get started with 3 times x squared. Well, you can't multiply those. We have a number and a letter. So that's just going to stay as 3x squared. And I'm actually going to put this under the other x squared. And you'll see why in a minute when we add them together. Next, we have 3 times negative 4x. We have 1 minus sign, so that's a minus. 3 times 4 is 12. And we have 1x, so the x is going to stay. And this is going to stay under the other part that's just with an x. And then 3 times 2, they're both positive, so that's a plus. 3 times 2 is 6. So we've done distributive property with the 2x, that's this top part here. And we've done distributive property with the 3, that's this other part here. So our final step is now to add these two parts together. So I'm going to draw this big line under here, and we're going to add these together. So 2x to the third, there's no other x to the third to combine with this. So it's just going to stay as 2x to the third. But here we do have some combination going on. This is adding, by the way. So negative 8x squared plus 3x squared. Think of it as dollars like before. You lost $8 and you got 3 back, but you're still down $5. So that's going to be minus 5. And remember that when you're adding and subtracting, you don't do anything with the exponents. It's just going to stay as x squared. Here we have plus 4x minus 12x. So you got $4 and then you lost 12. So you're down $8. So minus 8x. And then this plus 6 has nothing to combine with, so that's going to stay as plus 6. So there you go. When you multiply these two sets of parentheses together, you get this 2x cubed minus 5x squared minus 8x plus 6. It honestly looks more complicated than this, so would you call this simplifying? I guess. So one of the topics in algebra that I feel like a lot of people struggle on is long division, when you're dividing polynomials. Remember that a fraction is just the same thing as division, so if there was a divided by symbol instead of a fraction, that would mean the same thing. So to do this, we're actually going to do the same thing that you would have done in your elementary school class where you did long division, but we're just doing it with algebra. I know it's a lot harder that way, but it's kind of the same method. So this top part here, the first part of our division, we're going to write here, and we're going to put it inside of our division box, like this weird thing. And then on the bottom, this part here is going to go on the outside of our division box. And now we just need to follow the same steps as elementary school long division, which if you don't remember them, those are divide, multiply, subtract, and then bring down. And in the wise words of my elementary school teacher, you could remember this by the acronym, does McDonald's sell burgers? By the way, in case anyone was wondering, yes, McDonald's does sell burgers. So the first step is to divide. So we need to divide the first part of the inside by the first part of the outside. So 2 divided by 2 is 1. And by the way, our answer is going to go on top here. And then x squared divided by x. So think of this like x squared divided by x. X squared is the same thing as x times x. So 1x from the top and the bottom are going to cancel out. And that just leaves us with x. So this is going to be 1x, but we don't have to put the 1 here. That's unnecessary. So this is just going to be x. That's our division. The next step is m, which is McDonald's. Multiply. And we need to multiply this entire thing to what we just got as our answer here. So 2x times x, that is 2x squared. And then 3 times x is 3x. So division you only do with the first parts of each, but multiplication you have to do with the entire thing that's on the outside of our division box. The next step is to subtract. So we need to subtract these here, like this. But if we were to just add these together, that would be adding. So to subtract, we basically just have to change all of the signs on the bottom. So those were both pluses. These are now going to become minuses. Or if they were already minuses, you would make them pluses. And now let's go ahead and subtract. So 2x squared minus 2x squared, those cancel out, those turn to 0. And then minus 5x minus 3x, that's minus 8x. Think of it as dollars if it confuses you. And now the final step is b, which is to bring down. And the only thing to bring down is this minus 10. So let's bring it down to the bottom. and we just have to repeat the process. We only have to repeat it one more time because we've brought down everything we can. So first is division, divide. So negative 8x divided by 2x. 8 divided by 2 is 4. X divided by x, those cancel out both of the x's, so that just doesn't do anything. And then we have 1 minus sign, so the minus sign stays. Next is multiply. So 2x times negative 4. 2 times 4 is 8. The x stays. And then we have 1 minus sign, so the minus sign stays. And then also we have to multiply the 3 by the negative 4. 3 times 4 is 12. And there's 1 minus sign, so the minus sign stays. Next is to subtract. And remember that subtracting means we have to change all the signs on the bottom. So these minuses are going to become pluses. So negative 8x plus 8x, those cancel out. And here we have negative 10 plus 12. That's the same as 12 minus 10, which is 2. So as long as this number here at the bottom is 0, we're done. That's it. And this part right here, x minus 4, is our answer. But this is not 0. So that means we have a remainder. And dealing with a remainder is actually pretty simple. We just need to attach it to the end of our answer. So our remainder is going to be plus 2, but the 2 has to be over divided by our part that was outside of the division box. So we have to divide it by 2x plus 3. And that's all you have to do with a remainder. You just attach it to the end and then divide it by whatever we divided by originally. But yeah, this part at the top here, whatever you have left here is going to be your final answer. So our final answer is x minus 4 plus 2 over 2x plus 3. If you've clicked on this video, then congratulations, you've decided to start studying for your Algebra 2 final. But you're probably wondering, how am I supposed to learn an entire year's worth of math in just an hour-long video? Well, that's exactly what we're going to do. Here are some of the most important concepts you need to know if you want to ace your Algebra 2 final exam. So here's the first problem that we'll be doing. We need to solve for x in this equation. Now, to solve for x, we have to isolate the variable, which means we need to get x by itself. And we can do that by doing whatever we want to both sides of the equation. But we do have a problem here, and that is that we have an x on both sides of the equation. So we need to get rid of one of those. So we can either get rid of the 3x, and we can do that by subtracting 3x from both sides of the equation. But then we're just going to end up with negative numbers. You see, we have a minus 2x and a minus 3x. So personally, I would like it better if we got rid of the minus 2x to avoid negative numbers. So to get rid of minus 2x, we need to do the opposite of minus, which is plus. And we need to add 2x to both sides. So the minus 2x and the plus 2x cancel out. And on this right side, we just have plus 3, or 3. And then on the right side, we have 3x plus 2x. 3 plus 2 is 5. And then the x is going to stay. And then we have this minus 7 here that isn't being touched, so we're going to leave it as minus 7. So now we just have x on one side of the equation, but we need to get x by itself. So that means we need to get rid of the 5 and the minus 7. I think it's usually easier to get rid of the plus and minus before multiplication. So let's get rid of the minus 7 by doing the opposite of minus, which is plus. So let's add 7 to both sides. So the minus 7 and plus 7 cancel out. On the left side, we just have 5x. And on the right side, we have 3 plus 7, which is 10. And now we just have a one-step algebra problem. Now, this is really important. Whenever you see a number next to a letter in algebra, that means multiplication. Even though there's no sign in between, it's implied that it's multiplication. So we need to do the opposite of multiplication, which is division, to get x by itself. So the 5's cancel out. On the left side, we just have the letter x. And on the right side, we have 10 divided by 5. Remember that fractions are the same thing as division. So 10 divided by 5 is 2. And that means that our answer is x is equal to 2. So here's a really important skill that you need to have for your final, and that is to be able to graph a straight line. Now, in my opinion, the easiest way to graph a straight line is using slope-intercept form, which is y equals mx plus b. The m in this equation stands for the slope, and the b stands for the y-intercept. But there's just one problem. This equation here is not in slope-intercept form. So in order to graph this on our graph, we need to turn it into y equals mx plus b. And the way that we're going to do that is by getting y by itself, because in y equals mx plus b, y is by itself. So to get y by itself, let's first get rid of this minus 2x, because we could get rid of the 3 first, but then we'd have to divide everything by 3, and it would just get complicated. So this is a minus 2x, so I'll do the opposite of minus, which is plus, and add 2x to both sides. So these cancel out. On the left side, we just have 3y. But on the right side, we have 6 plus 2x. And we actually can't add these because they're not like terms. One has an x and the other one doesn't. So we're just going to leave it as 6 plus 2x. So now to just get rid of this 3 that's being multiplied to y, I'm going to do the opposite of multiplication, which is division. And in this case, we have to divide everything by 3 on the other side. So the 3's cancel out. On the left side, we just have the letter y. And on the right side, let's divide everything by 3. So 6 divided by 3 is 2. And then 2x divided by 3, well, 2 divided by 3 can't be simplified. So it's just going to stay as 2 over 3. And the x is going to stay. So here we have our equation with y by itself. And as you can see, it is in slope-intercept form, y equals mx plus b. These are swapped around. The mx is after the b. So if you want to just make it easier for your brain, let's just go ahead and flip these around. So we have our equation of y equals 2/3 x plus 2, and now let's just go ahead and graph it on our graph. So what is the slope of our equation? Well, remember that the number next to x is the slope, the slope. And in this case, that is 2 over 3. So 2 over 3 is going to be our slope. And this also means that b, our y-intercept, is going to be 2. So how do we plot this on our graph? Well, the y-intercept is going to be where the line crosses the y-axis. This big vertical line up and down, this is the y-axis, and the one left and right is called the x-axis. So if the y-intercept is 2, that means that it's going to cross the y-axis 2 squares above the center of the graph. So here's the center of the graph, and we need to go up 1, 2 squares. So this is where it's going to cross the y-axis. Now to plot a line, we actually only need to have 2 points, because once you have 2 points on the line, you can just connect them up and then have it extend infinitely in both directions. So let's use our slope of 2 over 3 to figure out another point of our graph. Remember that slope is also known as rise over run. So if the slope is 2 over 3, that means our rise is going to be 2, and our run is going to be 3. So let's start at the point that we just plotted, and let's go ahead and do our rise and run. So from this point, we are going to rise 1, 2 squares. And then from here, we're going to run 1, 2, 3 squares. And this means that right here, we're going to have another point of our line. Now, we could do that again, up 2 over 3, and plot another point here. But as long as you have 2 points, we're good. So we can just draw a line in between these 2 points. So I'm going to just attempt to draw a straight line and just hope for the best here. And here we go. This is the line that represents the equation, negative 2x plus 3y equals 6. So here's another problem about equations of lines. But instead of graphing it based on an equation, we need to come up with the equation ourselves based on this information. So we get 2 pieces of information. We know that the line is going to pass through the point negative 2, 3. And remember that negative 2 is the x-coordinate left and right, and 3 is the y-coordinate up and down. And this line is also going to be parallel to this other equation, this other line, which is y equals 1/2 x minus 5. Now we could try to write this equation again using y equals mx plus b. But there is one problem with this. We are able to find out the slope. Actually, lines that are parallel always have the same slope. So because the slope of this line is 1/2, then the slope of our new line is also going to be 1/2. But what's the y-intercept, or b? We have no way of figuring that out, right? Because we could just try to plot this on a graph, but that would just take too long. So instead, we can use a different format for when we know a slope and 1 point on the graph. And it's called point-slope form creatively. Point-slope form is y minus y1 equals m times x minus x1. So just like y equals mx plus b, the x and y are going to stay x and y. M is going to be our slope, which in this case is 1/2, because parallel lines always have the same slope. So we're just going to replace M with 1/2. That is our new slope. And then y1 and x1 are the coordinates of a point that we know is on the graph. In this case, we know that -2, 3 is on the graph, so we can just put those numbers in. So our x coordinate here, the number on the left, is -2. So instead of x1, I'm going to replace it with -2. And you'll see here that we actually have a double negative. We have minus minus 2. Two negatives make a positive, so instead of double minusing it, I'm just going to put a plus sign instead. And then our y coordinate of 3 is going to replace y1. So y1 is going to become 3. So now we have an equation of the line, but it would look a lot nicer if we just put it in slope-intercept form. So I'm going to simplify this as much as we can. First of all, I'm noticing that we have a number here in front of parentheses. And whenever you see this, you should be like, ooh, this is the distributive property, because the distributive property says that we have to take this number in front and multiply it out to both parts inside the parentheses. So 1/2 times x, that's just going to stay as 1/2 x. And then 1/2 times 2, half of 2 is 1. So that's going to be plus 1. And now we haven't done anything with the left side of this equation, so it's going to stay as y minus 3. And now we just need to get y by itself, just like slope-intercept form. So we just need to get rid of this minus 3. I'll do the opposite of minus, which is plus, and add 3 to both sides. So these cancel out. On the left side, we just have the letter y. On the right side, well, this 1/2 x is not a like term with anything, so that's just going to stay as 1/2 x. But we can actually add these two numbers together. 1 plus 3 is 4. So it's going to be 1/2 x plus 4. And this is actually our final equation. This is the line that's parallel to this other line and passes through -2, 3. Now for this next problem, let's kind of cast our minds back to the first problem where we had to solve for x. But this time we actually have to solve for two different letters, x and y. And we can only solve for two letters when we have two equations. So this is actually called a system of equations. There's two ways to solve a system of equations. There's substitution and elimination. Elimination is pretty much always faster. If you want to see substitution, I also have a video on that. But we're going to use elimination here. The goal of elimination is to add together these two equations to eliminate one of the letters. And then we only have one letter and we just solve for that letter. But if I was to add these two equations up, then nothing is going to happen, because I would have minus 5x plus 3x, so that's minus 2x, and then plus 2y minus a y, so we have 1y left, and then 4 minus 3 is 1. So we haven't accomplished anything, right? We still have an x and a y. So here's the question that I would always ask people when I'm tutoring someone in this topic. I would say it would be really convenient if this number here, for example, if we were trying to eliminate y, it would be really convenient if this was what number? Well, you might be saying, I would love if this number was a 2, because if it was a 2, then we would have plus 2y and minus 2y, they would cancel out, and we've eliminated the letter y, and then we just have the letter x. So we can't just go ahead and write a 2 into here, but we can do the algebra rule that says you can do whatever you want to both sides of the equation. So if we just multiply this entire equation by 2, then we're going to make this a 2 like we want, and we're still following the rules of algebra. So this first equation is going to stay exactly the same. But the second equation, we're going to multiply everything by 2. So 2 times 3x, 2 times 3 is 6, and the x stays. Then 2 times negative y is now negative 2y. And then 2 times negative 3, 2 times 3 is 6. And there's one minus sign, so the minus sign stays. And now we can go ahead and add these two equations together, and you'll see that we eliminate the letter y. So negative 5x plus 6x, that's the same thing as 6 minus 5. 6 minus 5 is 1, and the x is going to stay. But whenever you have 1 times a letter, the 1 is pretty useless, right? Anything times 1 is itself. So we don't have to write the 1. We can just leave it as the letter x. Then plus 2y minus 2y, those are exact opposites, so those are going to cancel out. And then we have 4 minus 6. If you're ever confused about negative numbers, think of it as money. So you earned $4, but then you lost $6. So you're down $2. And you'll see that we've actually already solved for one of our letters. X is equal to negative 2. So that is solving for x right there. X equals -2. But we don't just need to solve for x. We need to solve for x and y. So let's go ahead and solve for y now. To solve for y, we can use either one of these equations and just plug in -2 for x. And then that'll just leave the equation with y, and we can solve for y. So personally, I think we're closer to solving for y with this bottom equation because, there's not a 2 on it. So I'm going to use this bottom equation. Let's go ahead and rewrite this equation, but instead of x, we'll replace it with a -2 because they're the same. So it's going to be 3 times -2 minus y equals -3. So this can be simplified here. 3 times -2, 3 times 2 is 6, and 1 minus sign, so the minus sign stays, minus y equals -3. Now, continuing to get y by itself, let's get rid of the -6. The opposite of minus is plus, so let's add 6 to both sides. These cancel out. On the left side, we just have -y. Don't forget the minus sign. You don't want to forget that there's a minus here. And then -3 plus 6, that's the same thing as 6 minus 3, which is 3. And now the only thing in our way of getting y by itself is a minus sign on y. But remember that two negatives make a positive. So let's just slap a minus sign on both sides of the equation. Then these are going to cancel out and become a positive. And on this side, we just have -3, which means that y is equal to -3. And that's the other part of our answer. So our final answer is that x is equal to -2 and y is equal to -3. Or another way to write your answer is with coordinates. So remember that x comes first, then y. So we could write our answer as -2, -3, as if it was a point on a graph. So two ways to write your answer, but they're both correct. All right, let's get a little bit into functions. A function is whenever you see f of x or g of x or maybe occasionally h of x, but they all mean the same thing. The idea of a function is that you plug in a number for x and then you get something out for f of x, which is basically the same thing as y. You can think of f of x and y as the same thing. So this problem is asking us to solve for f of 2. And you'll notice that when we go from f of x to f of 2, we are replacing the letter x with the letter 2. 2 is like our input. That's what we're putting in, and we're trying to see what we get out. So on this side of the equation, the square root of 2x to the third over 5 minus x, we need to do the same thing. We need to replace x with the number 2. So let's go ahead and do that on this right side of the equation. So f of 2 is going to be equal to the square root of 2 times, instead of x, we're going to write 2 to the power of 3 over 5 minus, and again, we're going to replace x with 2. And now we just need to simplify this using our favorite thing in the world, the order of operations, which is PEMDAS, also known as GEMDAS, also known as BODMIS, also known as BIDMIS, also known as whatever you call it where you are. So I don't see any parentheses here. So let's go ahead and move on to E, which is exponents. And here we have an exponent of 2 to the power of 3. That's 2 multiplied by itself 3 times. 2 times 2 is 4, times 2 is 8. So we can replace 2 to the power of 3 with 8. So it's going to be 2 times 8 inside of the square root over 5 minus 2. Now 2 times 8 is equal to 16. So this is going to be the square root of 16. And what's the square root of 16? Well, what number do you have to multiply by itself to get 16? Well, 4 times 4 is 16. So the square root of 16 is 4. Now, I don't know why I'm going all the way to the right side of the screen, so let me just move this over. The bottom of our fraction here says 5 minus 2. 5 minus 2 is 3. So let's go ahead and simplify that. And all we have left is 4 over 3. That's not a fraction you can simplify, right? So we're just going to leave it as 4 over 3. And that's actually our answer. That is what f of 2 is equal to, 4 over 3. Now here's another graphing problem. We need to graph this equation. And it's not going to be a straight line because we have an exponent here, a power of 2. So it's probably actually going to be a curved line. Now, because it's not a straight line, this is going to be a little more tricky, but it is really important. So one way that you can graph basically any equation is to keep plugging in numbers for x, see what you get out for y, and then plot those points on the graph. But that would take a long time. So there's actually an easier way to do this. We can use something called transformations. And transformations are basically where you take a parent graph, the simplest graph that you can take, and then you figure out what the extra numbers are doing to it. So some examples of parent graphs are y equals x squared, or another common one is y equals the absolute value of x, or even just y equals x, that's a parent graph. But which one are we going to be using for this problem? Well, we're going to be using y equals x squared because we have a squared here. So we're basically going to graph y equals x squared. And then we're going to ask ourselves, what is this 2 doing to the graph? And what is this minus 1 doing to the graph? And then we just make those adjustments. So let's start by just graphing y equals x squared. And this is going to be graphed the same way every single time, so this is something you can just memorize. So what happens if we plug in 0 for x? Well, 0 squared, 0 times 0 is 0. So when we get 0 for x, we get 0 out for y. Now we just need to plot that on our graph. 0, 0 means we're not moving to the left or right at all, and we're not moving up or down at all. So that's literally just going to be right in the center of our graph. What if I plug in 1 for x? Well, if I plug in 1 for x, 1 squared, 1 times 1 is 1. So when I plug in 1 for x, I get 1 for y. So 1 for x means we move 1 square to the right because x is left and right. And then y equals 1 means that we need to move 1 square upward because y is up and down and positive numbers are up. So this point right here is also going to be a point on our parent graph. If I plug in 2 for x, then 2 squared, 2 times 2 is 4. So when I plug in 2 for x, I get out 4 for y. So that means we need to go 2 squares to the right and 4 squares upward. And we're going to plot a point right here. Now, what happens if I start plugging in negative numbers for x? Well, if I plug in negative 1 for x, negative 1 times negative 1 is positive 1 because two negatives make a positive. So when I plug in negative 1 for x, I get positive 1 for y. So negative 1 for x is left and right, and negative numbers go to the left. So I'm going to move 1 square to the left and 1 square up because y is 1. And in the same way, when I plug in negative 2 for x, I get positive 4 for y. So I'm going to move 2 squares to the left and 4 squares up. So when I plot my parent graph, I get this like U-shaped graph that I'm going to draw really terribly. And this is called a parabola. So now that we've graphed our parent graph, we just need to ask ourselves, what is the 2 doing to the graph and what is the minus 1 doing? The minus 1 is easier, so let's talk about this first. If we had a number on the outside of the parentheses, if we had a plus 1 or a minus 1 outside, that would move the graph up and down because, we're just adding or subtracting a number to y, and y is up and down. But in this case, the number is inside of the parentheses. So when it's inside the parentheses, that's also being squared, then we need to move the graph left and right. And left and right is the opposite of what you probably think. When you have a minus 1 in parentheses, that normally means to go to the left because negative numbers are on the left, but it's actually moving it to the right. And if you want to move to the left, you would use a positive number in the parentheses. So because this is a minus 1, we are going to move the entire graph to the right 1 square. So I'm going to do this in like purple because it's not our final graph. We still have to worry about the 2. But we're basically just going to replot our graph 1 square to the right. So each of these points are going to move 1 square to the right. And when we go ahead and connect up all of our dots, we're going to have another terribly drawn graph because I'm just so good at art. And here it is. Here's our new graph. And we can actually just go ahead and erase our parent graph. We don't need that anymore. But now what is this 2 doing? Remember that the 2 is next to the parentheses and there's no sign in between. In algebra, that means multiplication. So we are multiplying the entire graph by 2. Now this right here, the bottom of our graph, this is called the vertex. And basically that is always just going to stay in the same spot. All of our other points, we need to multiply their y values by 2. So this point right here is 1 square above the ground. We can just call this the ground, right, where the vertex is. So it's 1 square above the ground. Now it's going to be 2 squares above, because 1 times 2 is 2. We're doubling all of the heights. This point right here is also 1 square above, so now it's going to be 2 squares above. And now what about these points up here? Well, this point is 4 squares above the ground. 4 times 2 is 8. So it's going to be 8 squares above, and that's just like way off of the screen, so we're not even going to bother plotting that. And same for this one. This one's 4 squares above, so it's going to be 8, and it's off the graph. And this vertex is going to stay where it is. I should have plotted that earlier. So now let's go ahead and draw our final graph and just connect up these points. Obviously, we only have 3 points to work with because some of them are off the graph, but we'll just do our best. So now we can just go ahead and erase our purple line here because that's not even our answer. We'll just get rid of that. And there we go. This is the final graph of y equals 2 times x minus 1 squared using transformations. All right, let's get a little bit into imaginary numbers, or more specifically, complex numbers. Complex numbers are part real and part imaginary. So this right here is a complex number. We have a real part, -2, and an imaginary part, which is 4i. And just as a review, remember that I is equal to the square root of -1, because square roots are normally impossible to do for negative numbers. So we need to multiply these two complex numbers. And remember, it's multiplication because there's no sign in between these two sets of parentheses. And that always means multiplication in algebra. So whenever you have two sets of parentheses, something plus something or something minus something, and you want to multiply them together, you have to use a rule called FOIL. The letters of FOIL stand for the different steps that we have to do, which are first, outer, inner, and last. So let's follow each step one at a time. The first step is F, which stands for first. So we need to multiply the first parts of each set of parentheses together. So -2 times 3, 2 times 3 is 6, and there's one minus sign, so the minus sign stays. Next, let's do O, which stands for outer. So we need to multiply the outer parts together. So -2 times -5i. We're going to treat I as if it's just any normal letter in algebra. So 2 times 5 is 10. And then we have an I, so the letter I is going to stay. And then we have two negatives. Two negatives make a positive. So it's going to be plus 10i. Next, we need to do I, which stands for inner. So we multiply the inner parts together. So 4 times 3 is 12. We have one I, so the I is going to stay, and no negative signs. So this is also going to be a plus. And finally, we need to do the letter L, which stands for last. So we need to multiply the last parts together. Now, 4 times 5 is 20, and we have one minus sign, so the minus sign is going to stay. And then we have two i's, and remember they're being multiplied together. Whenever you multiply something by itself, that's the same thing as squaring. So I times I is I squared. Now that we've done the steps of FOIL, we basically just need to simplify this as much as we can. So I'm noticing that right here we have two different parts with an I on them, and that means we can combine them. They're like terms. So 10i plus 12i, 10 plus 12 is 22. And the I is going to stay because we have 10 i's, we're adding 12 i's, so we have 22 i's in total. And we haven't touched the -6, and we haven't touched the -20i squared. So those are all going to stay the same. Okay, we don't have any more like terms, right? We can't add an I and an I squared, so it looks like we're done. But there is one more important thing that we need to know because these are imaginary numbers. Remember that I is equal to the square root of -1. But if we square the square root of -1, then the square root and the squared are exact opposites. So they actually cancel each other out. So I squared is just the same thing as -1. So we can replace I squared with -1. And we can actually simplify that down now. So we have -20 times -1. Anything times 1 is itself, so that's just 20. But we have two negatives, and two negatives make a positive. So this is going to be positive 20, and everything else is going to stay the same. And now we actually have more like terms because we have two just regular numbers without letters. We have a -6 and we have a 20. So that's the same thing as 20 minus 6. 20 minus 6 is 14. And we haven't touched the 22i, so it's going to stay the same. And now there really is nothing else that we can do here, right? We have something with an I and something without an I. So we can't combine them. And this is our final answer, 14 plus 22i. And you'll notice that this is also a complex number. It has a real part, 14, and an imaginary part, 22i. All right, this problem and the next one are going to be about quadratic equations because there are so many different ways to solve them, and it's really important to know them. So for this first one, we need to solve it by factoring. Personally, I think factoring is the easiest way, And it's made even easier by the fact that we don't have a number in front of x squared. So we can use the easier version of factoring. If you want to learn how to do it when there is a number in front of x squared, then that is in the full factoring video in the description. But for now, let me just show you how to factor when there's not a number in front of x squared. So our goal with factoring is to eventually turn this equation into x plus something or x minus something in two different sets of parentheses. It's almost like doing the opposite of FOIL, like what we just did. We're taking the already FOILed equation and we're turning it into something that has to be FOILed. So we basically just need to find the two numbers that we will put in those parentheses. And the way we do that is by finding two numbers that add up to the number in front of x. So they need to add to this, and they need to multiply to the number that's by itself. In this case, that's minus 15. The signs are always included in these numbers. So positive 2 and minus 15. So the way I like to find these numbers is I just list out numbers that multiply to negative 15. And then I see, do these add to 2? So let's ignore the minus sign here for a second, right? The most obvious two numbers that multiply to 15 are 1 and 15, 1 times 15, right? But because this is minus 15, one of these numbers has to have a minus sign on it. And we are adding to a positive number, which means that the minus sign has to be on the smaller number. Because if we put the minus sign on the larger number, then they would add up to a negative number. And we have to add up to positive 2. So I'm always going to be putting the minus sign on the smaller number. So negative 1 times 15 is negative 15. But if we add these together, negative 1 plus 15, that's the same thing as 15 minus 1, which is 14. We're looking for 2. So this is way off, but it's a start. What other numbers multiply to 15? Well, the only other numbers I can think of are 3 and 5. 3 times 5 is 15. And remember that we have to put the minus sign on the smaller number because we're adding up to positive 2. So negative 3 times 5 is negative 15. And if we add these together, we get 5 minus 3, which is 2. That is what we're looking for, right? That's our magic number. So that means that our numbers that we're going to put in the parentheses are negative 3 and positive 5. So let's go ahead and do that. We're going to go ahead and set up our parentheses here, right? We're going to have x plus or minus something times x plus or minus something. It's still going to equal 0, just like in the equation. And now we're just going to plug in our two magic numbers. So the first parentheses are going to be x minus 3. The second set is going to be x plus 5. So now what do we do with this, right? Well, we're not going to FOIL it because that would just turn it back into the equation again. But there is a special thing we can do because the equation equals 0. Remember that anything times itself is 0. So if this part right here, if x minus 3 is equal to 0, then it would be 0 times this, which is 0. It doesn't even matter what this is equal to. And the same thing on the other side. If x plus 5 is 0, then the whole thing is 0. We don't have to worry about what x minus 3 is. So those are two different possibilities to make this equation true, either one being 0. So we can actually split this up into two different equations. On the left, we can have x minus 3 equals 0. And on the right, we can have x plus 5 equals 0. Because these are two different ways that this equation would be true. Two different ways it would equal 0. So now we just need to solve each of these equations, and they're each going to give us an answer. Quadratic equations usually have two answers. So to get x by itself, I'm going to do the opposite of minus, which is plus, and add 3 to both sides. These cancel out. On the left side, we just have x, and on the right side, we have 0 plus 3, which is 3. So x equals 3 is one of our answers. But let's go ahead and solve this to find our other answer. So I'm going to do the opposite of plus 5, which is minus 5 on both sides. These cancel out. On the left side, we just have x, and on the right side, we have 0 minus 5. Well, this 0 isn't doing anything, so it's just minus 5. And this is our other answer, x is equal to minus 5. So these are two answers. X is equal to 3 and x is equal to minus 5. All right, here's another quadratic equation for us to solve. And this one we need to solve by completing the square. So the idea of completing the square is to factor it, but turn it into an equation where it's like a perfect factor. So for example, if we were to factor this and it turned into x plus 4 times x plus 4, then that would be great because that's just the same thing as x plus 4 squared. And then that would be even easier to solve because we just have to square root both sides. Now to prepare for completing the square, that rhymed. I'm going to just move this minus 9 to the other side of the equation. And I'll show you why in a second. So let's go ahead and add 9 to both sides. So these cancel out. On the left side, we just have x squared plus 8x. And I'm going to leave a little bit of room here because we're going to figure out what number needs to go here to make it a perfect square. On the other side, we have 0 plus 9, which is 9. So what number do we have to add here to make this a perfect square? Well, the way that we find that out is by taking this number here next to x. We divide it by 2, and then we square it. Don't ask why, just that's what you do to figure out what number needs to go here, the missing number. So 8 divided by 2 is 4, and then we square 4. 4 times 4 is 16. So that's the number that needs to go here to make this a perfect square. But remember that in algebra, we can't just randomly add a number to one side of the equation. We have to do it to the other side. So let's add 16 to the other side of the equation as well. And 9 plus 16 is equal to 25. So there we go. 25 is what we're going to have on the right side of our equation. So now what happens if we try to factor this? Well, we have to find two numbers that add up to 8 and multiply to 16. And those are 4 and 4, because 4 times 4 is 16, 4 plus 4 is 8. And you'll know this because the number that you need to use for factoring is always what we got when we divided this by 2. Because we divided 8 divided by 2, which is 4, and then, we squared it after that. But this number right here is always going to be your magic factoring number. So in the parentheses, we're going to have x plus 4 times x plus 4. But anything that you multiply by itself is just the same thing as squaring. So this is the same thing as x plus 4 squared. And that's going to equal 25. We haven't touched the 25 from earlier. So now how do we solve for x? Well, we just need to get x by itself. And the most annoying thing right now is that the whole thing is being squared. So let's do the opposite of squaring, which is square rooting. So I'm going to square root both sides. The square root and the squared cancel. And on the left side, we're going to have just x plus 4. Now on the right side, we have the square root of 25. But here's something you need to remember. The square root of 25 can be 5, because 5 times 5 is 25. Or negative 5 times negative 5 is also positive 25. So whenever you're square rooting both sides of an equation, what you're really doing is plus or minus square rooting. So the square root of 25 is 5, because 5 times 5 is 25. So on the right side, we're going to have plus or minus 5. And just like before, because we had two answers last time, this is also going to have two answers. We need to solve this for x as if it was plus 5 and then as if it was minus 5. So let's go ahead and split this up into two equations. On the top here, we're going to have x plus 4 equals 5. We're also going to solve x plus 4 equals negative 5. And we're going to find out what our two answers are. So solving this first one here, x plus 4 equals 5. Let's get rid of the plus 4 by doing minus 4 on both sides. These cancel out. On the left, we just have x. And on the right, we have 5 minus 4, which is 1. So x equals 1 is one of our answers. Now on the bottom here, let's also subtract 4 on both sides to get rid of the plus 4 next to x. Plus 4 and minus 4 cancel out. On the left, we just have x. And on the right, we have negative 5 minus 4. So think of it as money. You lost $5, and then you lost another $4. So in total, you are down $9. So minus 9. And this means that minus 9 is another answer. So x equals 1 and x equals minus 9 are both answers to this equation. All right, I'm tired of talking about multiplication, so let's talk about division. Here we have two polynomials, and my official definition of polynomial is stuff with multiple things in it. So here's stuff, right? And this stuff has multiple things, which means that this here is a polynomial. That's the fancy math term for it. So there's basically two main methods that we can use to divide two different polynomials. There's long division, which is cool and all, but long division is long, in case you didn't know. And the other way to do it is synthetic division. Synthetic division is easier and faster, but we can only do it if this part here that we're dividing by is x plus a number or x minus a number. So if there's like an x squared in here, then you're out of luck. You got to use long division. So because we have just x minus 2, we can go ahead and use synthetic division. And to set up our synthetic division problem, we need to do a little bit of artwork, I guess. So we're going to start by taking this number here next to x, including the minus sign, right? We're going to take the opposite sign of that. So instead of minus, it's going to be plus 2. And we're going to put it inside a little box, just isolated on its own. So instead of minus 2, we're going to put plus 2, and we're just going to put it in this little box. Now, next to the box, I'm going to list all of these numbers, not including the letters and exponents, just the numbers in front. The fancy math term for that is coefficients, but they're just the numbers in front. So we have 2 next to x to the fourth, and then we have minus 6, don't forget the minus signs, next to x to the third. Now, there is one missing. We don't have an x squared. So whenever we skip a letter, we just put a 0 there. So we're not going to go straight to 3. We're going to put a 0 for x squared because we don't have one. Then we just have x to the first, x by itself, that's 3. And then we have a 13 to wrap it all up. Then finally, I'm going to draw a little line underneath here to leave room for some numbers. And we're going to draw another line here to make another box on the bottom right. And I'll show you what to do with that later. So now we're just going to follow the steps of multiplying and adding. Multiply and add over and over. And eventually we're going to have our answer down here under this line. We're going to have our answers right in front of us. So we start by bringing down our first number, which is 2. That's going to be the first number of our answer. And then we multiply and add. So multiply to the number in the box. 2 times 2 is 4. And then we add. -6 plus 4, you lost $6, you got 4 back, so you're still down $2, so minus 2. Then we keep following the steps, multiply and add. So multiply, -2 times 2 is -4. And then add, 0 minus 4 is -4. Multiply, 2 times 4 is 8, and there's one minus sign, so the minus sign stays. And then add, 3 minus 8 is -5. Multiply, 2 times 5 is 10, and there's one minus sign. And then add, 13 minus 10 is 3. And just by multiply, add, we have now listed our answer down here at the bottom. So we're going to ignore this part here in the extra box. So just kind of pretend that this 3 isn't here for a second. All right. This right here is going to be our answer. And we're going to list it using the x to the third, x to the second, that kind of stuff. So -5, the number all the way to the right, not including the box, is going to be the number by itself. Then every time you go to the left, we add an x. So -4 is going to be the number in front of x. -2 is going to be the number in front of x squared. And +2 is going to be the number in front of x to the third. And if you had more numbers, it would be x to the fourth, x to the fifth, and so on. So we just need to copy this down. 2 times x to the third minus 2 times x to the second minus 4 times x minus 5. And there you go. That is our answer. Almost. You see, this would be our final answer if this number here was 0. But it's not 0. This number here is 3. That is our remainder. The remainder is kind of like the remainder you had when you did long division back in 3rd grade or whenever you learned long division. And the way you deal with the remainder is actually not that bad. You just have to add it to the end. So we have to add it plus 3, but then you have to put it over what we divided by, which is x minus 2. So that's how you always deal with a remainder. You add it to the end, you attach it to the end, but it has to be over x minus 2, or whatever you divided by. So there you go. This is our final answer to our synthetic division problem. All right, let's go back to functions. Remember when we just did the f of x problem where you plug in the number for x, see what you get? Well, this is what's known as a composite function. You're like, what does this say? Like fog of -2? Well, this little circle means composite. And that is when you have a function inside of another function. So we have two functions here, f of x and g of x. F and g don't mean anything different other than that they're two different functions. And here's what this fog thing means. Basically, this is read as f of g of -2. So in this case, g is going to be inside of f. It's basically exactly like what I just read. This is the same as f of g of -2. So we're basically taking a function and putting it inside of another one. Now, how are we going to do this? Well, let's start by finding out what g of -2 is. Then once we know that, that's going to be the number that we use to solve for the whole thing, f of whatever that number is equal to. So what is g of -2 equal to? Well, we're going to use g, which is -3x minus 4, but instead of x, we're going to replace it with -2 and find out what it's equal to. So g of -2 is -3 times x, which is now -2, minus 4. And now let's just go ahead and solve this. So -3 times -2, 3 times 2 is 6, and two negatives make a positive, so it's going to be positive 6. We haven't touched this minus 4, so it's going to be 6 minus 4, which is 2. So g of -2 is equal to 2. So here where we have f of g of -2, we know that this is now equal to just positive 2. So now to figure out what this composite function is equal to, let's just find f of 2. F of 2 is going to be equal to, and now we're just going to use our other function, x squared over 4. But instead of x, we're going to put the number 2. So that's going to be 2 squared over 4. And now we can just go ahead and simplify this. So 2 squared, that's 2 multiplied by itself. 2 times 2 is 4, over 4. And remember that a fraction is the same thing as division. So 4 divided by 4 is 1. And there you go. 1 is the answer. We have solved our composite function. All right, composite functions are cool and all, but what about square root equations? I don't even know why I'm trying to do a good segue. This has nothing to do with the last problem. Now, for this problem, we're actually going to do it very similarly to the other time where we graphed a parabola, like the squared equation. It's basically going to be the same thing, but with a square root. So we talked about parent graphs before, right? Like we had y equals x squared, we had y equals the absolute value of x. Well, what's the parent graph going to be in this case? Well, we have a square root over x. So our parent graph is going to be y equals the square root of x. So this is always graphed the same way every time. And then we have to ask ourselves, what is the plus 1 doing, which is inside the square root? And then what is this plus 2 doing? That is outside of the square root. So let's graph our parent graph, y equals the square root of x. What do we get when we plug in 0 for x? Well, the square root of 0 is 0. So again, we get 0 for x and 0 for y. That's the center of our graph. That'll go right here. What if I plug in 1 for x? Well, the square root of 1 is 1. So I get out 1 for y. So x being positive 1, x is left and right, and positive numbers go to the right. So we need to move 1 square to the right. And then y is 1, y is up and down, and positive numbers go up. So we need to move 1 square up, and here's our point right here. Now, what if we plug in 2 for x? What do we get? Well, the square root of 2, we can't really simplify, right? If you put that in your calculator, you're going to get some crazy decimal, like 1.41, I think, or something like that. So actually, a better number to plug in this case would be 4, because that's our next perfect square. The square root of 4 is 2, because 2 times 2 is 4. So this way we get just nice whole numbers. So when x is 4, x is left and right, so we need to go 4 squares to the right. And then y is 2, so we only need to go 2 squares upward. And we're going to have a point right here. Now, what happens when we start plugging in negative numbers? Well, if I plug in -1 for x, we get the square root of -1, which is I guess. Remember that negative square roots are impossible. You can't multiply two of the same number to get a positive or to get a negative number. And so that's why we have imaginary numbers, but you can't plot an imaginary number on a graph unless it was like a fancy imaginary number graph or something, I don't know. So assuming that we're just talking about real numbers, because that's all we can graph right now, this is not, we can't put in negative numbers. That's just not possible. So we're actually only going to take the positive side of our function, of our graph. So let's go ahead and connect up these dots. It's not quite a straight line. It is a little bit curved. It's almost like a sideways parabola, and we only have half of the parabola. And again, this is how you always graph y equals the square root of x, so you can just memorize this. 0, 0, 1, 1, and then 4, 2. So now let's ask ourselves, what is this plus 1 doing, and what is this plus 2 doing? Let's talk about the plus 2 first, because it's easier. It's on the outside of our square root. We're just attaching a plus 2 to the end. This means we're adding 2 to y. So whenever you have a number added to the outside, it's going to move the graph up. Or if you're subtracting it on the outside, it's going to move it down. So I'm going to take all of the points of our graph and move them up 2 squares. So this point's going to move up 2, and that's going to go right here. This point's going to move up 2, that's going to go here. This graph's going to, or this point is going to move up 2. and it's going to go there. And when we connect the dots up again, we're going to get ourselves this shiny new graph. And we can go ahead and erase the old one. All right, we've adjusted the graph for the +2, but now what about the +1? Well, it's not going to move the graph up another 1 square because it's on the inside of the square root. And that's basically the same as if the +1 was inside of the parentheses when we did our little x squared problem. So this actually moves it left or right. And remember, it's the opposite of what you think. When it's on the inside of parentheses, then plus moves it to the left and minus moves it to the right. So a +1 is going to move everything 1 square to the left. So this point here is going to move 1 square to the left. This point here is going to move 1 square to the left. And this point here is going to move, you guessed it, 1 square to the left. And we can go ahead and connect up all of these dots, just like before. Now we can erase our purple line because we don't need that anymore. And here we go. This is our final graph of y equals the square root of x plus 1 plus 2. I know it looks a little goofy, and you might be tempted to go ahead and put an arrow on the other side here, but remember that these are still like negative numbers. Our square root graph cannot go farther to the left. It stops here and only goes infinitely this way. So you might have thought that we were finally done with doing functions. Well, if you thought that, then you were wrong. I'm sorry. For this one, we have an f of x, and instead of finding like f of a number like f of 2, we need to find f to the -1 of x. You're like, I didn't know we could put exponents on the letter f here. Well, actually, this isn't an exponent. This f to the -1 basically just means that it's an inverse function. This is how we write it. So how do we find an inverse function? Well, we basically just need to rewrite this function, and I'm actually going to do it with the letter y instead of f of x, because I think it's a little bit easier to do it this way. Remember that y and f of x are basically the same thing. So to get the inverse function, we basically have to just swap x and y. So y is going to become x, and x is going to become y. So when we do that, we get x equals y squared minus 4. So here's our inverse function, technically, I guess. But remember that f of x is always by itself in these functions. So let's just try to do the same thing. Let's try to get y by itself. Let's get rid of the -4 first. I think that's easier. So we'll do the opposite of -4, which is +4, and add 4 to both sides. So these cancel out. On the left side, we just have y squared. And on the right side, we have x plus 4. That's a letter and a number. We can't add those together. So that's just going to be x plus 4. It's going to stay the same. Then we just need to get rid of this squared next to y. So I'm going to do the opposite of squaring, which is square rooting. So I'm going to square root both sides. So the square root and the squared cancel. On the right side, we're just going to have the letter y. And on the left side, we're just going to have the square root of x plus 4. There's nothing you can really simplify there, right? We can't take the square root of letters. So that's going to stay the same. So now normally for a function, the y part is on the left. So I'm just going to swap this around. So this is going to become y equals the square root of x plus 4. And now here's the final step. This y, remember, we just turned it into y to make it easier. So let's go turn it back to f of x. But instead of f of x, we're going to write our inverse function notation, which is f to the -1 of x. And there you go. This is our inverse function. F to the -1 of x is equal to the square root of x plus 4. All right, let's think all the way back to problem 1 where we solved for x. We need to solve for x in this equation, but the letter x is trapped inside of an exponent. It's stuck in the exponent on the number 9. So how do we solve this? Well, ideally, this would be really nice if these two big numbers, or what they're called bases, if they were the same number. Like if this was 3 to the power of x minus 2 equals 3 to the power of -6, if these are going to be equal to each other, if they're going to be the exact same, then these exponents will have to be the same as well. So we could just ignore the bases and just set the exponents equal to each other. X minus 2 is equal to -6. But unfortunately, we don't live in that ideal world where the bases are the same number. So instead, what we can do is we can force the bases to be the same number. So let's think about the number 9 here, right? How can we turn the number 9 into the number 3 using exponents? Well, 9 is the same thing as 3 squared, because 3 times 3 is 9. So if we turn 9 into 3 squared and just leave everything else the same, then I'll show you how we can make these two bases the same. Right here now we have a power of a power. We have 3 to the power of 2 to the power of x minus 2. So whenever you have a power of a power, you can actually just multiply the two powers together. So this is the same as 3 to the power of 2 times x minus 2. And that's going to be equal to 3 to the power of negative 6. So now we are in that ideal world where both bases are the same. So let's ignore the bases and just set the exponents to be equal to each other. So 2 times x minus 2 is going to be equal to negative 6. And now we can just solve for x. So I'm going to move this up to the top. Here we have a number in front of parentheses, which means we have to use the distributive property. So I'm going to multiply the 2 out to the x and to the minus 2. So 2 times x, you can't multiply those. That's just going to stay as 2x. And 2 times negative 2. 2 times 2 is 4. And then we have 1 minus sign, so the minus sign stays. And that's going to be equal to negative 6. And now let's just continue solving for x. So I'm going to get rid of the minus 4 first, because I think that's easier than getting rid of multiplication. So I'm going to do the opposite of minus 4, which is plus 4 on both sides. So the minus 4 and plus 4 cancel out. On the left side, we just have 2x. And then on the right side, we just have negative 6 plus 4. So you lost $6, then you gained 4 back. You're still down $2. So minus 2. Then we just have multiplication, 2 times x. So I'm going to divide both sides by 2. The 2's cancel out. On the left side, we just have x. And on the right side, we have 2 divided by 2, which is 1. And 1 minus sign, so the minus sign stays. So now that we've solved for x, our final answer is that x is equal to negative 1. Okay, let's talk about logarithms for a little bit. Here we have two logs, and we have to add them together. So remember that a log is just whatever exponent you have to put on the small number to get the big number. So for example, log base 2 of 2/3, it's 2 to the power of what would give you 2 over 3. But chances are I don't think you'd be able to tell me off the top of your head what exponent would make it 2/3. So let's not do that immediately. So to solve this, instead we can use a property of logarithms. One of the properties is I think it's called the addition property or the multiplication property. I forget what it's called, but basically when you add the two logs together, you can multiply the insides, multiply the big numbers. But this only works if the bases, the small numbers, are the same. So because these are both log base 2, we can add them together. So by combining these two logs, we're just going to get one log with a base of 2. And the inside is going to be 24 times 2/3. Well, 24 is the same thing as 24 over 1. And if we multiply these two fractions together, 24 times 2 is 48 over 1 times 3, which is 3. And 48 divided by 3 is 16. So these two logs are going to combine to become log base 2 of 16. So now what is log base 2 of 16? Well, remember, it's the exponent that you have to put on the small number. So I'm going to use x because it's a number that we don't know, right? That's the classic letter in algebra for unknown numbers. It's some exponent that you have to put on 2 to get 16. So what is that exponent? Well, an exponent is just how many times you have to multiply 2 by itself to get 16. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So we have to multiply 2 by itself 4 times to get 16, which means that this missing number here is the number 4. And that actually is the answer to log base 2 of 16. The log base 2 of 16 is equal to 4. And by the way, if a question ever says, put this log into exponential form, then this is what it's talking about. Turn the log into the exponential form where you have a number to the power of x is equal to another number. Your midterm exam is coming up and you don't remember anything you've learned this year. Yay. Well, don't worry. I'm going to go over the most important topics that you're going to need to know for your Algebra 2 midterm. All right, so here's the first problem that we'll be doing in this video, and I want you to start thinking about this problem while I quickly explain how this video is going to work. This video is going to have 10 problems, and they're all just going to be the basic things that you need to know for the Algebra 2 midterm. Now, obviously, every midterm is different, so make sure you check with your teacher or professor to make sure that you know what's going to be on the exam. So for this video, you're probably going to get the most out of it if you pause the video when I show each question and try to do it yourself first. And then you can unpause the video and see where you went wrong or what you did right. So let's get started with this first problem where we have to solve for x, and we have some numbers and x's here. Well, whenever you see something that looks like this, where we have a number in front of parentheses with pluses and minuses and stuff, this should immediately stay in your head. This is the distributive property. And what the distributive property means is this 2 in front here, it's being multiplied to the parentheses. And we have to basically multiply the 2 out to both parts of the parentheses. So to the 2x and to the 3, or the minus 3, actually, the minus sign stay. So we're going to have 2 times 2x first. 2 times 2 is 4, and then the x stays. And then we have 2 times 3, which is 6, and then the minus sign stays as well. And then that's just going to equal 5x minus 12. Now, we need to get x by itself, but it's kind of hard to get x by itself when x is on both sides of the equation, because we need it to be on one side. So what we're going to do is we're going to subtract one of these x's from the equation. Now you have two options here. You can subtract 4x from this side, or you could subtract 5x from this side. I personally would subtract the 4x, because if you subtract the 5x, then you're going to be doing 4 minus 5, and you'll have negative numbers. And we like to avoid negative numbers as much as possible. So we're going to subtract 4x from both sides. Because remember, whatever you do to one side of the equation, you have to do the other side. That's like the basic rule of algebra, right? So these cancel out. And on the left side, you're just left with not 6, minus 6. Remember, the minus signs stay. Equals. And then we have 5x minus 4x. We had 5 of them, and then we lost 4, so we only have 1 left. So you would put 1x, but you don't have to put 1 in front because that doesn't do anything. You can just put x, and then minus 12. And now we just need to get x by itself on this side of the equation. And the only thing in its way is this minus 12. So to get rid of it, we'll do the opposite of minus, which is plus. So we will add 12 to both sides. These cancel out. And on this side, you're just left with x. And on the other side, we have minus 6 plus 12, which works the same way. I know that negative numbers can get confusing, but remember, these are interchangeable. This is the same thing as saying 12 minus 6. And 12 minus 6 is 6. So our final answer is x is equal to 6. Now, for each of these problems, if you got it wrong or you're confused about something, I do have a longer video about each of these topics. So in the description, I have a link to the video that corresponds with each problem. So if you got it wrong, you can go ahead and review that video. All right, here's our second problem for the midterm review, and this is a graph-related problem. There's going to be a few of these in this video, but this one we don't actually have to graph anything. We just need to write the equation of this line. So how do we do that? Well, go ahead and pause the video and try it yourself, and then unpause and see how you did. All right, so the form for a straight line, and this is really important to know, so make sure you've got this down. It's y equals mx plus b. And these are the dumbest letters in the world because m stands for slope, and b stands for y-intercept. So basically, to find the equation of this line, we just need to find out the slope and the y-intercept. So what are the slope and the y-intercept? Well, the y-intercept is where it crosses the y-axis. Remember, the y-axis is where all the y numbers are, the up and down. So this is y. This is the x-axis, the one from the left to the right. So where does it cross this y-axis? Well, if we start in the middle, to get to the graph, we have to go down 1, 2, 3. So right here is where it crosses. And because we went down 3, that means the y-intercept is minus 3. And now what about the slope? Well, slope is rise over run. So what we're going to do is we're going to pick out another point on this graph, but I would recommend picking out, you can pick out anything, but I would pick out a point like this one here because it doesn't have any fraction numbers in it. It's right on the corners of these boxes. So to get from this point to this point, you have to rise 1, 2, which means our rise is going to be 2, and it has to run 1. So the run is 1. And 2 divided by 1 is 2, because anything divided by 1 is itself. So our slope is 2. So to find the equation of this line, all we have to do is rewrite y equals mx plus b, but with the numbers that we know. So in this case, this is going to be, and we'll write it over here, y equals m, which is our slope we just found out is 2, so 2x, and then we have plus b, and the y-intercept, or b, is minus 3. But we don't have to write plus minus 3. That just means minus. So we'll have minus 3. So there we go. The equation of our line is y equals 2x minus 3. All right, here's our third problem for this video. Go ahead and pause the video and try it yourself. So we need to solve for x and y, and remember that you can solve for as many letters as you want as long as you have that many equations or more. So we can solve for both x and y, which is 2 letters because we have 2 equations. Now there are 2 main ways to solve this. You can solve it either using substitution or elimination, and either one is fine here. I'm going to do it using elimination, but you're free to use substitution as well. If you were to do substitution, you would basically just try to get a letter by itself and then substitute it in for the other equation. So elimination, the goal of that is to try to eliminate one of the variables from the equation, right? Our goal here is to add up these 2 equations and eliminate a letter, but we can't do that right now. So for elimination, the question that I always ask is, it would be really convenient if this number right here was what number? And people usually say, well, it would be really convenient if this was a 2, because we have minus 2 plus 2, and then they cancel out, and then we get rid of y. But we can't just put a 2 here and make it into a 2. But we can use the rule of algebra, which is you can do something to both sides of the equation. So we're going to multiply this entire equation by 2. So the top equation is just going to stay the same, 2x minus 2y equals 10. But this bottom equation, we're going to multiply everything by 2. So 3x, 3 times 2 is 6, so that becomes 6x. Y becomes 2y. And then 7 times 2 is 14. And now if we add together these 2 equations, you'll see that we have 2x plus 6x, which is 8x. And then these cancel out, minus 2 plus 2. And then over here on this side, we have 10 plus 14, which is 24. And now we just have a one-step equation to solve for x. We have 8 times x equals 24. So to get rid of this 8, we'll do the opposite of multiplication, which is division. So we will divide both sides by 8. These cancel out, and we just have x on this side equals 24 divided by 8, which is 3. So x is equal to 3. But this doesn't actually mean that we're done with the problem, because remember, we need to solve for x and y. Well, to do that, we can use either of these equations. In this one, y is by itself, so it'll be easier to use this one. So we're going to bring back this equation, but instead of x, we're going to put 3, because we know that x is the same as 3. So we're going to have 3 times 3 plus y equals 7. 3 times 3 is 9, so we have 9 plus y equals 7. And now we just need to get y by itself. So 9 is being added to y. So to get rid of it, we need to do the opposite of addition, which is subtraction. So we will subtract 9 from both sides. These cancel out. And on this left side, we're just left with y equals, and then 7 minus 9. Well, think of this as dollars. We had $7 and we spent 9. So we have 2 less than before. So it's going to be minus 2. So there we go. Our final answer is x is equal to 3 and y is equal to minus 2. Or if you wanted to write it the fancy way, you can write this as coordinates. And with coordinates, x always goes first. So it would be 3, negative 2. So that is our final answer. And as a reminder, if you were confused about that or got it wrong, I have a full video on it that you can watch in the description. All right, it's time for another graph-related problem. We need to describe the end behavior of this weird graph. So if you think you can do it, go ahead and pause the video and try to do it yourself. All right, so what is end behavior? Well, shockingly, it's the behavior of the graph as it ends. And that should make you ask a good question, which is, doesn't this graph never end, right? It's got an arrow on it. It goes infinitely, which is exactly why end behavior has a bunch of infinity signs. I just realized, why is there an x here and not a y? Okay, hold on. So basically, there's 2 ways that this goes for x, or left and right. As x goes to the left, I know this is going really far up, but it's also going to the left, and it's going to keep going to the left infinitely, and it's never going to stop. So this is going to be approaching what we call negative infinity, which means it goes infinitely in the negative direction. But x also approaches positive infinity this way, because it's just going to keep going to the right farther and farther until the end of numbers, which doesn't exist. So the whole point of end behavior is figuring out what is y doing, the up and down, as x does things, goes to the negative infinity and positive infinity. So we're going to phrase this as x approaches negative infinity, y is going to approach something, right? And then as x approaches positive infinity, y is also going to do something. So let's find out what that something is that y is going to do. So let's start with this, as x is approaching negative infinity, going farther to the left every time, right? What is y doing here? Remember, y is up and down. Well, it seems to be going up. It's infinitely going up. And up is positive numbers. So as x is approaching negative infinity, y is approaching infinity. So we're going to put infinity here. Now what about on this side? Well, here x is approaching positive infinity because it's going to the right. So what is y doing? Well, y is going up and up and up. It's just going to keep going up for eternity until it runs out of numbers. So y is also approaching positive infinity. So there we go. Our final end behavior is as x approaches negative infinity, y approaches infinity. And as x approaches infinity, y also approaches infinity. There's a lot of infinity signs, but that's because the graph doesn't actually end. So there we go. This is our final answer. All right, so here's the fifth problem in this video. We need to describe the transformation of this equation and graph it. So go ahead and try this on your own, pause the video, and then unpause and see how you did. So the three types of parent graphs are y equals x squared, which is going to be a bowl shape like a parabola, right? We have y equals the absolute value of x, which is pretty similar, except it's a V shape. And then we just have our classic y equals x, which is just a straight line with a slope of 1, because this number in front is 1, because you can't see it. So that would just be a diagonal line going like this. So which one of these is it? Well, in this case, we have y equals, and then this stuff, but we have a squared here, which means our parent graph is going to be y equals x squared. So let's go ahead and get rid of these other ones. So you could just graph a parabola by going like this and being like, good, perfect, but I mean, we want to be a little more accurate than that. So just graph the numbers here when y equals x squared. So if x is 0, 0 squared is 0, right? Now let's say you put in 1 for x. If you put in 1, you would get out 1 squared, which is 1, because 1 times 1 is 1. So when you go 1 to the right, you go 1 up. And then finally 2 squared, if you go 2 to the right, you will get 2 squared. 2 times 2 is 4. So when you go 2 to the right, you go 4 up. So we'll go right here. And remember that parabolas are symmetrical. So when there's a point here, there's also a point here. It's like a mirror. This thing here is a mirror. And then this one will mirror image to right here. And now we can just go ahead and draw our bowl shape, and we'll do that like this. So this is saying that we need to transform this graph. So we need to describe the transformation and graph it. So the question here is, what is this minus 2 doing? Because that's the only thing that's different, right? Other than these parentheses, but the minus 2 is in the parentheses. So the important thing here is to understand what these plus and minus signs do. So for example, if I had y equals x squared, then let's say I added a plus 1 to this. We are adding 1 to y, which means, well, y is up and down. So the whole thing is going to go up by 1 squared. And likewise, if I was to do like minus 2, then the whole thing would move down 2 squares. So you would graph the same thing, but downward. But in this case, we have it inside the parentheses. The minus 2 is also being squared. And that means we need to either move it left or right. But when it's inside the parentheses, it's actually the opposite of what you might think. A minus sign in parentheses actually means going to the right, and a plus sign means going to the left. If you want to understand more of why that is, you can go ahead and check out the full video in the description. But all you really need to remember is that if it's in the parentheses, it's left or right, and it's the opposite of what you might think it is. So minus means to the right. So we need to move the entire graph 2 squares to the right. So we're going to move 1, 2 this way, and we will just plot each of these points the same way as before, but 2 to the right. So we'll have 1 here, because that's 2 to the right. We'll have 1 here, we'll have 1 here, and 1 here. And we'll go ahead and graph this. So there you go. This is our new graph, and this is the answer. This green line is actually just the parent graph. It's not part of the answer, but if the instructions say you need to graph the parent graph, then include this green line as well. And it also says here that you need to describe the transformation, which is simple. We moved it 2 squares to the right, so you would say right 2. That's it. That's all you have to do. So this is our final graph. All right, congratulations. You've made it halfway through this video. You've finished 5 questions out of 10. So keep it up. And yes, I know it's another graphing one, but I promise this is the last graphing problem of this video. So we need to graph this equation. And you might be asking yourself, well, what shape would this graph even be in? Well, this graph, because we have a quadratic form here, we have a squared part, an x squared, we have a normal x part that's not squared, and then we have a part that doesn't have x at all. This means it's a quadratic equation, and quadratic equations are always in the form y equals ax squared plus bx plus c. And just so you know, if these were out of order or you had some things on the other side of the equation, you can just rearrange it into this format and then graph it. So how are we gonna graph this, right? Well, first of all, we can graph our y-intercept, and the y-intercept is actually really similar to the y equals mx plus b that you might be used to for straight lines. And our y-intercept is just c. It's the number by itself without an x on it. In this case, that's not 1, minus 1. Remember, the minus sign is included. So we can just go ahead and right away plot a point right here because it's where it crosses the y-axis, the up and down line. Remember, this is y and this is x. We have to start in the middle, and for minus 1, that means going down 1. So we would go down 1 to this point. But now here's the most important part that's going to help you plot a bunch of other points, and it's called the axis of symmetry. The axis of symmetry is basically our mirror image line from before. Remember that we graphed a bowl-shaped graph here. Our axis of symmetry is basically just the mirror in the graph. So this would be the axis of symmetry here. And you can use this to plot a bunch of points because you can see that whenever you get a point over here, there's also a point over here. So how do we find our axis of symmetry? Well, the formula for the axis of symmetry, and this is something that you're just going to have to remember, it's always negative b over 2a. So in this case, we have to figure out b. B is not 2, negative 2. B is negative 2, but it's negative b. So that's negative 2, which 2 negatives make a positive, so that's just 2. And then 2a, well, that's 2 times what's a? Well, a is, there's nothing there. Well, remember, if you don't have a number in front of a letter, that just means it's 1. So a is 1. And 2 times 1 is 2. So we have 2 divided by 2, which is 1. So our axis of symmetry is, well, the axis of symmetry is a line. Technically, this is x equals 1. So our axis of symmetry, how we graph it, is we start in the middle, and because it's x equals 1, we need to go to the right 1. And right here, we're going to draw our line. This is going to be where the axis of symmetry is. Now, this axis of symmetry doesn't just tell us where it's a mirror image, it also tells us where the bottom of the bowl is. Because remember, when we have a bowl-shaped graph here, we have our axis of symmetry. The bottom of the bowl is always on that line. So to find it, all we have to do is plug in 1 for x, because remember, x is 1 on this entire line. We need to plug in 1 back into the equation and see what we get for y, and that'll tell us where to put our point on this graph. So we're going to take this equation, and we're going to do y equals x squared now becomes 1 squared, because remember that x is 1, minus 2 times x is 1, and then minus 1. So 1 squared is 1 times 1, which is 1, minus 2 times 1 is 2, minus 1. And now we have to do it left to right. So 1 minus 2, we gained $1 and then lost $2, so we're down $1. So negative 1 minus 1, we lost $1 and then lost another $1, so that's minus 2. So in this case, y is equal to minus 2. So on this red line, our bottom of the bowl is going to be we'll start right here at y equals 0 and go down 1, 2. So we're going to have a point right here. Now, to get the most accurate parabola, we need to have 5 points, which seems like we have to do a lot more to get the rest of the points. But there's an easy way to get another point here. Remember, this is a mirror image. So if we have a point right here, there also has to be another point on the other side of the mirror. So this is 1 square away from the mirror. So 1 square away on the other side is another point. So now we have 3 points, and all we have to do is figure out one more point, do its mirror image, and then we have 5 points. So I'm going to pick out whatever point is going to go here on this line here, because why not? So on this line, we know that x is equal to 3, because, well, right here, we have to go to the right 1, 2, 3 to get here. So x is equal to 3 here. And to figure out where to place the point here, we'll do it the exact same way as we did with the axis of symmetry, the red line. So we're going to plug in 3 into this equation and see what we get. So we're going to have y equals 3 squared minus 2 times 3 minus 1. 3 squared is 9 because 3 times 3, minus 2 times 3, which is 6, minus 1. 9 minus 6 is 3, minus 1 is 2. So y is equal to 2. So on this part here, where x is 3, we need to go up 1, 2. And we're going to have a point right here. Now we have 4 points, and we only need 1 more. And that's easy. Remember that this is a mirror image. So this is 2 away from the mirror. So 2 away on the other side of the mirror is going to be another point right here. And now we have all the points that we need. So we're going to go ahead and draw the bowl that connects all these points. So yes, I know this is the worst bowl that I've ever drawn, and it's really messy, but it's fine. This is our final graph of y equals x squared minus 2x minus 1. All right, congratulations, you have finished the graphing part of this video, which, if you're like me, is really good news. But we're not done with quadratic equations, because you can still solve quadratic equations without graphing. And there are tons of ways to do that, but in this case, we need to solve it by factoring. So go ahead and pause this video, try to solve it for yourself, and then unpause and see how you did. All right, so how do we factor? Well, if you don't have a number in front of here, like let's say we're ignoring this number, we would have to find two numbers that add up to the number in front of x and multiply to get the number that's not next to x. But in this case, we do have a number next to x squared, which means we have to do it a slightly different way, and that's called the x method. Now, there's a chance that your teacher or professor is teaching you a way other than the x method, and in that case, you can either just do it their way, or you can ask the teacher if you can use the x method, because in my opinion, this is the easiest way to understand it, but it's totally up to you. So first of all, we need to multiply what's normally our multiplying number, the number that we have to multiply to, and do it times the number in front of x squared. We have 2 times 3, which is 6, and then we have 1 minus sign, so minus 6. So this is going to be our new multiplying number. And then our adding number is still going to be the same. It's going to be plus 5 here. So we have to add to 5. So we need to find two numbers that multiply to negative 6, but add up to 5. How do we do that? Well, let's go ahead and find the factors of 6, and we'll go ahead and ignore the minus sign for now. So first of all, there's the obvious one of 1 times 6, right? 1 times 6 is 6. But to get negative 6, we need to make one of these negative, because remember, if one of the numbers is negative, then the negative carries over. But we can also tell that the negative number will always go on the smaller number because we are adding to a positive number. If we were to make the bigger number negative, we would always add to a negative number, and we need to add to a positive number. So in this case, we're going to make the 1 the negative number here. So negative 1 times 6 is negative 6, but if we add negative 1 and 6, well, that's the same thing as 6 minus 1, which is 5. And that's the number we are looking for. So we found our two numbers, negative 1 and 6. So what we're going to do is we're going to take those two numbers and put them on the sides of our x. So we're going to have negative 1 and 6. Now in normal factoring, what you would do is just take those two numbers and put them in, negative 1 and 6, and then give yourself an equation and then solve it. But in this case, we have a 2x squared. So we're going to have to do one extra step. What we need to do is take this number 2 and divide either of these two numbers here on the sides by 2. You can divide the negative 1 by 2, but then you have fractions and no one wants to do that. So we're going to divide the 6 by 2 instead. And 6 divided by 2 is 3. So our two numbers are actually negative 1 and 3. So we're going to do it the same way. We're going to put negative 1 and plus 3. But in this case, we have a 2x squared, which means one of the numbers in front of here isn't going to be x, it's going to be 2x. And it's always going to be the one that's the opposite of the parentheses where you divided by 2. I know that was confusing, but let me show you. In this case, we divided the 6 by 2 to get 3. So this number here, we divided by 2 to get to this number. So we need to put 2x on the opposite parentheses. So this one right here. And this one is just going to stay as x. And the reason that we do that is because if we were to do FOIL, which is how you go from this back to this, we have to follow the steps of FOIL. So first is f, which is first, and that would be 2x times x. That's why we did this in the first place, to get 2x squared. But then you have to do outer, and outer is the outer ones here. So 2x times 3. So that is why we do the opposite parentheses, is because in FOIL we have to multiply the outer ones, and we get 2x times 3. So the last thing we can do here to solve for x is recognize that this is being multiplied to get 0, and anything times 0 is 0. So if just 2x minus 1 is 0, the whole thing is 0. And likewise, if x plus 3 was 0, the whole thing would be 0. So we can split this up into two equations. So we'll have 2x minus 1 equals 0, and we'll have x plus 3 equals 0. And just a reminder that you can only do this if it equals 0. So we're going to solve for x in this equation. We can get rid of the 2 or the negative 1. Let's get rid of the negative 1 first because it's less attached to the x. If we divided everything by 2, we'd have fractions, and no one wants to do that. So we're going to add 1 to both sides. These cancel out, and on this side we're just left with 2x. And on the other side we have 0 plus 1, which is 1. And now we just have a one-step problem. And this is multiplication, because whenever you don't have a sign, that means multiplication. So we'll do the opposite of multiplication, which is division. We'll divide both sides by 2. These cancel out, and you just have x equals 1 over 2, which is 1/2. So 1/2 is one of our answers. And now on the other side, we have x plus 3 equals 0. Well, this one's a little bit easier because it's just one step. We have a plus 3, so we need to do the opposite of plus, which is minus. So we'll subtract 3 from both sides. These cancel out, and we just have x equals 0 minus 3. This 0 isn't doing anything, so it's just minus 3. So our two answers are 1/2 and minus 3. Or if you wanted to write it the fancier way, you can do x equals and then these fancy little bracket thingies, which are what you use for a set of numbers. And normally you'd put it from least to greatest. So we'd have minus 3, 1/2. So our final answer is x is equal to negative 3 and 1/2. All right, here's problem number 8 out of 10. We're almost there. And we need to do the same thing. We need to solve for x. It's another quadratic equation. But in this case, we need to use the quadratic formula. So go ahead and pause the video, try your best to do this, and then unpause and see how you did. All right, so the quadratic formula is that formula that you can basically only remember if you use it a million times or if you listen to the quadratic formula song, which you can go ahead and watch that after this video. You're going to stay here. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So how do we even use this? Well, we're going to use it the same way as before when we had the form, if you remember from last time, ax squared plus bx plus c. So what is a? Well, a is going to be equal to whatever's in front of x squared, which in this case is, well, there's nothing here, but that means it's 1. So a is equal to 1. B is the number in front of x. And remember that it's not necessarily going to be in this order every time. You might have to rearrange the equation around. But in this case, b is going to be negative 4. Remember, the negative sign stays. So b is negative 4. And then finally, c is 8 here, positive 8. So to use the quadratic formula, all we have to do is plug these numbers into the a, b, and c and see what we get. So we're going to have negative b is negative 4, so negative negative 4, which is just positive 4, plus or minus the square root of b squared. So that's negative 4 squared minus 4 times a, which is 1, times c, which is 8. And then that's all going to be over 2 times a, and a is 1. All right, so let's go ahead and clean up what we have here. We have x equals 4 plus or minus the square root of negative 4 squared. Well, that's negative 4 times negative 4. 4 times 4 is 16, and two negatives make a positive. So we'll have positive 16 minus 4 times 1 times 8. Well, anything times 1 is itself, so this 1 isn't doing anything. And 4 times 8 is 32. And that's all going to be over 2 times 1, which is 2. And now let's go ahead and clean up this subtraction here. So we'll have x equals 4 plus or minus the square root of negative 16, because 16 minus 32 is negative 16. If you weren't sure of that, you could always put it in your calculator, don't worry. And then over 2. So you may be noticing a problem here, and that is we have a negative number in our square root, which in ordinary circumstances you would say you can't do that. So the answer is no answers, right? Well, that's why we have imaginary numbers. So if you don't quite remember imaginary numbers, I also have a video on that. But essentially, all you need to know is that the letter I is the square root of -1. So what we're going to do is we can split up the square root of -16 into the square root of +16 times the square root of -1, because 16 times -1 is -16. And you can do this with square roots. So the square root of +16, well, that's 4, because 4 times 4 is 16. So we'll have 4 times, and then the square root of -1 is I. So the square root of -16 is 4i. So we're going to go ahead and simplify that down. 4 plus or minus 4i over 2. And we can actually simplify this even further. You may notice that this top part, we can divide both of these by 2, because remember, fractions are the same thing as division. So let's go ahead and, just to show this, we'll split this up into 2 fractions. So we have 4 divided by 2 plus or minus 4i divided by 2. Now 4 divided by 2 is 2 plus or minus, and then 4 divided by 2 is still 2, and then the I stays. So if you wanted, this could just be your answer, 2 plus or minus 2i, because you can't combine real numbers and imaginary numbers. So that's it. But you could also write this, because plus or minus, this actually means 2 answers. This means 2 plus 2i, and it also means 2 minus 2i. So if you wanted to write this using the fancier set format, you would say that our 2 answers are, fancy brackets, 2 plus 2i and 2 minus 2i, and then close the brackets. So there you go. This is our final answer, 2 plus or minus 2i. All right, problem number 9. We have 2 problems left. We need to expand x minus 2 to the third. So if you think you know how to do this, go ahead and pause the video, try it, and then unpause and see how you did. All right, so what is an exponent? Well, remember that means you're just multiplying it by itself 3 times. So that's x minus 2 times x minus 2 times x minus 2. Now you could just do FOIL on these and then do FOIL again on this, and you just have, I mean, that would take a while. I mean, maybe it wouldn't take the longest in the world, but you might also have to do problems like x minus 2 to the 7th, and then that's x minus 2, and you're going to be here forever if you try to do that. Which is why we have a great invention from Pascal, and it's in the shape of a triangle. Can you guess what it is? That's right, it's Pascal's triangle. So remember that Pascal's triangle always starts with 1 at the top, and then 1, 1, and then 1's all the way along the sides. But to figure out the numbers inside the triangle, we add the numbers that are above it. So to figure out this number, we take the 2 numbers above it, 1 and 1, and add them together. 1 plus 1 is 2. So this number of Pascal's triangle is 2. And then we do the same for these ones. So 1 plus 2 is 3, and 2 plus 1 is 3. And you can continue with this all the way down, but we actually don't need to for this problem. So we have a 3 here as our exponent, which means that we need to use the 3rd row of Pascal's triangle. But this does not include the row here that's just the number 1. This is just considered the 0th row. And every row after this counts. So this is row number 1, this is row number 2, and this is row number 3, which is the one that we're looking for. So we're going to use this row of Pascal's triangle. So I'm going to move it up here. So how are we going to use this to our advantage? Well, we can use these numbers as the beginning numbers of each term in our expansion. So what we're going to do is, for our first term, it's going to start with a 1. But I won't write the 1 because the 1 doesn't do anything. But we're going to start out with this first part here, all being to the 3rd. So we're going to have x to the 3rd. Now our second term is going to start with a 3, because we have a 3 here, right? So we're going to put 3, and then every term that we have, we're going to take away one of the x's and replace it with the second part here. So instead of x to the 3rd, it's just going to be x to the 2nd. We're taking away an x, and we're replacing it with 2, which is our second number here. Our third term is also going to start with 3, right? So we're going to have 3, and then we're going to take away another x. So we had 2 of them, we had x to the 2nd. Now we just have x by itself. And we're going to add another 2. So we're going to have 2 squared. And then our final term is just 1, so I won't write the 1 because 1 doesn't do anything. and we're going to take away that last x. So there's not going to be any x's anymore. Instead, we're just going to have 3 2's, so 2 to the third. Now, you may notice I haven't been putting signs in here. So how do we figure out the signs? Well, if you have a plus here, then all of these would be pluses. So if it's expand x plus 2, it would be plus, plus, plus. But if it's minus, you just have to alternate minuses and pluses. So we'd start with a minus. We'd have x to the third minus this, plus this, minus this. And if you had more terms, then it would be plus, minus, and so on. I know that was a little confusing, so if you need a little more explanation of that, then I do have a video on it that you can watch in the description. So let's go ahead and simplify what we have here. X to the third, you can't really do anything with that, so that's x to the third, minus, and now we have 3 times 2, which is 6, x squared, plus, and now we have 2 squared. 2 squared is 4, times 3 is 12, because 4 times 3 is 12. So we have 12x, and then we have minus 2 to the third, that's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So we'll have 8 here. And there you go. This is our expansion. That's what it means by expanding. I guess another word for it could be simplifying, because you're simplifying it. But, I mean, do you really want to say that this is more simple than this? I mean, they can get really complicated. So that's why we use the word expand, because we're not going to pretend that this is simpler. All right, you've made it to problem 10 of this video. Congratulations, this is the last problem. And after this problem, you'll know all the main things that you need to know for the Algebra 2 midterm. So for this final problem, we need to use synthetic division to find this. We have a big, long polynomial. That's the fancy name for this, polynomial, because poly means multiple, and nomial means, I think it means names, but that doesn't make sense. I don't know, whatever. It's got multiple things, and then we're dividing it by x minus 3. Remember that there are 2 ways to divide polynomials. We have long division, which can be used to divide any polynomials, but we can also use synthetic division if we just have x plus a number or x minus a number. And synthetic division is faster, but you can only use it in these cases. So what we're going to do is we're going to draw a little box here, and we're going to put whatever number is here with the opposite sign. So in this case, we have minus 3, so we're just going to put 3. And if this was x plus 3, then we would have to put minus 3. And then we're just going to list all of the beginning numbers here. So we have 2x to the third, so it's going to be 2, negative 9, 13, and negative 12. And if you were missing something, like if you didn't have an x to the third, but you had an x to the fourth, then you would just put a 0 there as a placeholder. Then we're going to draw a line all the way through here. And in front of this last number, we're going to put another line here. And this is going to be where our remainder is. So all we have to do is move this number down. So that's 2. Then we're going to multiply it with the number in the box. So that would give us 2 times 3, which is 6. And then we add these up, and that'll give us our next number. So negative 9 plus 6, we lost $9 and then gained 6 back. We're still down $3. Then we have 3 times negative 3. 3 times 3 is 9. And the minus sign stays. 13 minus 9 is 4. 3 times 4 is 12. And then negative 12 plus 12, those cancel out and give you 0. So this is going to be what we use to write our final answer here. But how do we use these? Well, remember, this is going to be our remainder, but we don't have a remainder here, so we're not going to worry about that. This number here is going to be by itself. This number is going to be the x term. This is going to be x squared. And so on. If we had a number here, that would be x to the third. So let's go ahead and write our final equation. We're going to have 2x squared minus 3x plus 4. And now we don't have a remainder, but let me just show you what would happen if we did have a remainder. Let's say that this was 5, for instance. Then we would have plus 5, and then you have to divide it by what we divided by at the beginning. So you would put it over x minus 3. But in this case, we don't have a remainder, so we don't have to do that. So there you go. Our final answer to this division is 2x squared minus 3x plus 4. Congratulations, you've decided to start studying for your Algebra 2 final exam. But what are you supposed to study? Everything? Well, in this video, I'm going to go over 10 problems with some of the most important concepts that you need to know for your final exam. So here's the first problem that we'll be doing in this video. We need to solve for x in this inequality. So there are multiple ways that we can do this. One way I'm seeing that you might have thought of is we can just take this minus 2 and divide it out. But this pattern here also means that we can use the distributive property. So the distributive property says that when you have a number like this in front of parentheses, then you need to multiply the number out to all the parts of the parentheses. In this case, we only have 2, but you can have more parts than that in the parentheses. So we're going to multiply the minus 2 out to the 4x first, and then the minus 3. So negative 2 times 4x, remember that the minus signs always have to stay. So 2 times 4 is 8, and then we have one minus sign, so the minus sign stays, and then we have an x, so the x stays. And then here we have minus 2 times minus 3. So 2 times 3 is 6, and then we have 2 minus signs, and 2 negatives make a positive. So that's going to become positive 6. And then on the other side, the less than negative 2 is just going to stay the same. So now our goal is to just get x by itself. And we can do that by first getting rid of this minus 8 or this plus 6. I think it's better to get rid of the plus 6 first because the negative 8 is more attached to the x, so we'll get rid of that last. So let's go ahead and subtract 6 from both sides. And the reason that we're doing that is because the opposite of addition is subtraction. So these would cancel out. On this side, we just have negative 8x. And on the other side, we have less than negative 2 minus 6. Think of this as dollars. You lost $2 and then lost another 6. So you've lost $8. And now we just need to get x by itself. And now we just need to get rid of this minus 8 to get x by itself. But what's the opposite of this? There's no sign at all. Well, when there's no sign, that means it's multiplication. So we're going to imagine there's a multiplication sign here, and the opposite of multiplication is division. So we'll divide both sides by negative 8. The negative 8's cancel out, and on this side we just have x, and on the other side here we have negative 8 divided by negative 8. Well, dividing anything by itself makes 1. And you'll notice that I've been avoiding writing the sign here, and there's a reason for that. Because we divided by a negative number. We divided by negative 8. And you also have to do this if you multiply by a negative number. Whenever you do that, you have to flip the inequality sign. So it was less than, now it's greater than. So our final answer is x is greater than negative 1. And if you wanted to check your work, you can always plug in a number that's greater than 1 into the equation and see if it's true. And then maybe try plugging in a number less than 1 and make sure that the equation is not true. Now, before we get into this next problem, I just wanted to let you know that for most of the problems we do in this video, I have a full video about that type of problem that you can watch in the description. So our second problem here is we need to solve for x and y. We have 2 equations. And remember, you can only solve for a certain amount of letters if you have that many equations or more. So if we had like 3 letters and only 2 equations, then we couldn't solve it. So there's 2 main methods to solve a system of equations. There's substitution and there's elimination. Elimination would be if we added these 2 equations together and it canceled out a variable. So that would be really convenient if this number was a 2, for example, and then we added these together and the plus 2y and minus 2y would cancel out. Now we could use elimination with this by multiplying this first equation by 2 and then solving it, but I think substitution will probably be easier in this case. For substitution, we need to take one of these equations and get a letter by itself. And y here is already pretty much by itself, so I think we're going to use this equation. So how can we get y by itself here? Well, the only thing in its way is this minus 3x. So to get rid of it, we can do the opposite of minus 3x, which is plus 3x. So we'll add plus 3x to both sides. These cancel out. And on the left side, we just have y. And on the other side, we have 2 plus 3x. Well, the 2 doesn't have a letter, and the 3x does have a letter. So we can't actually add these. So we're just going to leave it as 2 plus 3x. So now that we know that y is equal to 2 plus 3x, we can take this second equation, and it's important that you do the other equation, the one that we didn't just use, and we replace y with 2 plus 3x. So we're going to rewrite the equation, but instead of y, we're going to put in parentheses 2 plus 3x. And then everything else is going to stay the same. So now we can see that we don't have any more y's in this equation. We only have one letter, which is x. I mean, x shows up in 2 different places, but they're both x. So all we need to do is simplify this down and solve for x. So immediately I'm noticing that here we have the same pattern that I was showing you last problem, which is the distributive property. So we can multiply out this 2 to both parts. But remember that this isn't just a 2, this is a minus 2. So we also have to distribute the minus sign. So here we have negative 2 times 2. Well, 2 times 2 is 4, and then we have 1 minus sign. So the minus sign is already here. I already wrote it. Then here we have minus 2 times 3x. 2 times 3 is 6, and then the x stays. And again, here we have 1 minus sign, so the minus sign stays as well. And then the minus 6 is going to stay the same over here. So what else can we simplify here? Well, we have two numbers with an x in them, which means that we can combine them. That's called combining like terms. So we have 4x minus 6x. We had 4 and then lost 6, so you're down 2. So that's minus 2x. And then everything else is going to stay the same. So the minus 4 we didn't touch, so that stays the same. And then this minus 6 is still the same. And now we can just get x by itself with a two-step problem. Again, we'll get the minus 4 out first because it's less attached to the x. So we have minus 4, the opposite of minus is plus. So we'll add 4 to both sides. The 4's cancel out, and on the left side we have minus 2x, and on the right we have negative 6 plus 4. So you lost $6, you gained 4 of them back, but you're still down 2. And now we have multiplication here, so we can do the opposite of multiplication, which is division. We'll divide both sides by minus 2. The minus 2's cancel out, and I'll write this over here because we're running out of room. We have x equals negative 2 divided by negative 2. Well, dividing anything by itself makes 1, so x is equal to 1. So we've successfully solved for x, but the problem is asking that we need to solve for x and y. So how would we solve for y in this case? Well, all we need to do is plug in 1 for x in either of these equations and see what we get for y. I'm going to use this first equation because y is closer to being by itself, so it's going to be easier to use this one, but you can use the bottom one as well. So we're going to rewrite the first equation, but instead of x, we're going to write 1. So we're going to have minus 3 times 1 plus y equals 2. Negative 3 times 1, anything times 1 is itself, so that's minus 3, and then everything else is going to stay the same. And now we can just get y by itself by getting rid of this minus 3. The opposite of minus is plus, so we'll add 3 to both sides. These cancel out, and we just have y equals 2 plus 3, which is 5. So y is equal to 5. And our final answer is x equals 1 and y equals 5. Another way to write your answer for a system of equations is to write them as coordinates of a graph. So if you have parentheses and then you put the two numbers, x always goes first and then y. So you could just write it as 1, 5. And this is another way to write your answer. All right, here's our third problem, and this is going to be a graphing problem. So we need to graph y equals, well, what do these lines mean, right? Well, these lines mean absolute value. So this is saying y equals the absolute value of x plus 3. So how do we graph this? Well, you could plug in numbers for x and see what you get for y, and then, you'll get a bunch of points, and then you'll just connect them. But we can actually do this a faster way. For this problem, we can use something called transformations. So we need to first find what the parent graph is, and then find out what this plus 3 is doing to it, and then just adjust it. So our parent graph is just what the equation would be, but without all the extra things added on. So the three main types of parent graphs are y equals x squared, there's y equals the absolute value of x, and then there's just y equals x. So in this case, we're using y equals the absolute value of x. And this plus 3 is what's being added on afterward. So we need to first graph the parent graph. So the y equals the absolute value of x is in the shape of a V. And the V starts in the middle here, and then it just goes diagonally like this. So you'll want to make sure that it hits all these little corner points in the boxes here. And then it's going to go the same the other way. And if you weren't sure if it was a V shape, well, you can just think about it logically. Absolute value just means that you take whatever the number is and make it positive if it's not already positive. So y is the same as x here, right? If you go to the right 1, you go up 1. If you go to the right 2, you go up 2. So it's always the same x and y, except on the left side where x is negative, it's just y, but positive. So now we need to figure out what this plus 3 is doing. So basically, the graph is going to go up, down, left, or right. There's also other types of transformations, like, for example, if you put a 2 here, then you're going to squish the graph together. Or if you put a minus sign here, then it's going to flip the graph upside down. I have a full video of the types of transformations if you want to watch that. But here we need to figure out what this plus 3 is doing. Now, if the plus 3 was on the outside of the absolute value signs or parentheses, if we were doing like x squared, for example, then it would move the graph up. Or if it was -3, it would move the graph down. But when the number is inside of the parentheses or the absolute value signs, then it moves it left or right. And when we're moving left or right, it's the opposite of what you probably think. Normally, positive means numbers to the right and negative means numbers to the left. But when we're moving graphs left and right, it's actually the opposite. +3 is going to move it to the left. So if the problem asks to describe the transformation, then you would just say it moves to the left 3. But now we need to graph that. Well, we're just going to take this little point, this little anchor point, I guess, the point where the tip of the V is, and we're going to move it to the left 3 squares. And this will be the new tip of our V. And now we just need to regraph our V, but 3 to the left. So we're going to go ahead and draw a V just like we did before. And now this parent graph, because we've already graphed our final graph, we don't need this anymore. So we can just erase it. And this here is the final graph of y equals the absolute value of x plus 3. All right, let's get into some imaginary numbers. Remember those? So we just need to simplify this expression. And in this case, that means we're multiplying because we have two sets of parentheses and they're just right next to each other without a sign. So that still means multiplication. And in this case, we would actually call these complex numbers. This would be a complex number because we have both a real part, 3 is a real number, and an imaginary part, 2i is imaginary. And it's important to remember what I even means. So remember that I is just a short form for writing the square root of -1. Remember that square roots of negative numbers don't exist. They're impossible. So that's why they're imaginary. They don't exist in the real world. So with both imaginary numbers and with real numbers as well, whenever you have two sets of parentheses here with a plus or a minus sign in each of them, these are called binomials, and when we're multiplying two of them, we have to use FOIL. So to multiply these, we need to follow the steps of FOIL. So the first one is F, which stands for first. So we need to multiply the first parts of each of the sets of parentheses. So 3 times 5 is 15. The second step of FOIL is O, which stands for outer. So we multiply the outer parts of the problem. So 3 times, not 4i, -4i. Remember that the minus signs always stay. So 3 times 4 is 12. And then we have one negative sign, so the negative sign stays. And we also have one I, so the I stays as well. Then we need to do I, which stands for inner. So we multiply the inner parts here. So 2i times 5, 2 times 5 is 10. And then the I stays. And then finally, we need to do L, which stands for last. So we multiply the last parts. So 2 times 4 is 8. And then we have two i's, so that makes I squared. And then we have one minus sign, so the minus sign stays. And now we just need to simplify this down. So just like if I was a variable or just like x or something, we can combine these two like terms. We have two numbers with an I in them. So -12i plus 10i, you lost 12, you gained 10 back, but you're still down 2. So that's going to be -2i. And the rest of the equation is going to stay the same. So there's no more like terms that we can combine, so you might think that we're done. But remember that I is the square root of -1, and we don't need to change all the i's into square roots of -1, but we do have to do that for I squared, because it might turn into something else. So we're going to rewrite this equation, except instead of I squared, we're going to replace I with the square root of -1. And when we square it, you'll notice that we have contradicting things here. We have a square root, and then it's being squared. So those actually cancel out, because those are the opposites of each other. So the square root and the squared cancel. And when we rewrite this equation, then we're only going to have -8 times -1. That's all that's left here, -1. So you'll see that when we squared an imaginary number, it turned into a real number again. So we can simplify this as well. So we'll have 15 minus 2i, and then -8 times -1. 8 times 1 is 8, and two negatives make a positive. And then we can actually simplify this as well because we have 15 plus 8. Those are both real numbers. 15 plus 8 is 23. And then the -2i stays the same. And there is now nothing that we can do, so this is our final simplification. All right, here's the fifth problem in this video. We need to solve for x in this equation. But in this case, we can't just get x by itself like normal because we have an x squared. And that makes this a quadratic equation. Now, there are tons of ways to solve quadratic equations. There's, you can graph the equation, you can factor it, there's completing the square, there's the quadratic formula. But some of those methods don't work all the time, like factoring, you can't always factor. Graphing is just really dumb. So although we could probably factor this, there's one method that works all the time, and that's the quadratic formula. So I think that'll just be easier to do here. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, and that's all going to be over 2a. And if you didn't already have that memorized, just go look up a quadratic formula music video and you'll never forget it. So all we need to do is, to use the formula, we just need to plug in a, b, and c and see what we get for x. But it would be helpful to know what a, b, and c are in the first place, right? So a is going to always be the number that's in front of x squared. So in this case, a is going to be 3. B is going to be the number that's next to x. So that's going to be minus 2. The minuses stay as well. The minuses basically always stay in algebra. And then our c is going to be the number by itself. In this case, that's minus 8. And a, b, and c were in order this time. A was on the left, and then b, and then c. But that's only because the equation was already in order. We had it x squared, x, and then the number by itself. So if the equation's out of order, you'll probably have to put it in order before you can just go A, B, C. So now let's just go ahead and use this formula. So all we have to do is plug in the numbers. It's just the hard part is being careful about all the signs and making sure that we're not making a mistake. So let's go ahead and start plugging in our numbers. We have minus B, and B is minus 2. So this is going to be minus 2, plus or minus the square root of b squared. B is minus 2, so that's going to be minus 2 squared, minus 4, and then a. A is 3, and then c. C is negative 8. And then this is all going to be over 2 times a, and a is 3. So it's going to be 2 times 3. And now we just need to simplify this down, which may take a while, but we'll just take it one step at a time. So first we have negative 2. 2 negatives make a positive, so that's just going to become positive 2. Plus or minus the square root of negative 2 squared. Remember, when you're squaring, that just means multiplying by itself. So negative 2 times negative 2 becomes positive 4, because 2 negatives make a positive. And then here we have negative 4 times 3 times negative 8. Well, you could put this in your calculator if you wanted. 4 times 3 times 8 would be 4 times 3 is 12, times 8 is 96. But in this case, we actually have two minus signs. We have a minus sign on the 4 and a minus sign on the 8. Two minuses make a positive, so it's going to be plus 96. And then that's going to be over 2 times 3, which is 6. And now we can simplify this even more. So 2 plus or minus the square root of 4 plus 96, which is 100, over 6. And now I'm going to go ahead and move this up so we can simplify this even more. We have 2 plus or minus the square root of 100, which is 10, because 10 times 10 is 100. And now we don't have anything else to simplify, except for the fact that we have a plus or minus here. And you might have been wondering what this even means. Well, this means that we are actually going to have two answers. There's an answer if this was a plus, and there's an answer if this was a minus. So we need to split this up into two problems. We have 2 plus 10 over 6, and we have 2 minus 10 over 6. So let's simplify the first one. 2 plus 10 is 12 over 6, and 12 divided by 6 is 2. So 2 is one of our answers. And now if we look at the other one, we have 2 minus 10 over 6. 2 minus 10 is minus 8 over 6. And this is just going to stay as a fraction, but we can actually simplify this fraction because we can divide both the top and the bottom by 2. So negative 8 divided by 2 is minus 4, and 6 divided by 2 is 3. And you can't simplify 4 over 3 anymore. So that's going to be our second answer, negative 4 over 3. So our final answer is that x is equal to negative 4 over 3 and positive 2. And if you wanted to check your answer, you could plug in both of these numbers into the equation and see if it gets you 0. So let's go back to the graph and talk about domain and range. If you've done any sort of graphing problem in algebra, you've probably been told that you need to find the domain and range of the graph. But what do those even mean? Well, here's the easiest way to think about it, in my opinion. Domain is just all of the numbers that you can put in for x. So any numbers that you can put in, possibly, are going to be in the domain. And then the range is the same thing. It's all the numbers that you can possibly put in, but for y. And remember that x is left and right on a graph and y is up and down on a graph. That's important to know. So first of all, let's look at the domain for x. What numbers can we put in for x? Well, it doesn't look like there's anything stopping us from putting in any number for x. And by the way, when I say put in a number, I mean like when you have put in x as your input and then you get something out for y. So like for example, we could put in 1 for x because 1 means going 1 to the right. And if we put in 1, then we get 1, 2 for y. So when we put in 1 for x, we get 2 out for y. So it doesn't look like there's anything stopping us. And you might think, well, wait a minute, we can't put in, for example, 4. 4 is 4 squares to the right, and we don't hit anything for y, right? But these lines actually go on infinitely. And for a parabola, I know it looks like it's going to stop at some point, but these actually are going to keep going infinitely to the right, and this is going to go infinitely to the left. So we can put in whatever we want for x. So that means our domain is going to be all real numbers. Or another way to write this is to say that you can go from negative infinity to positive infinity. So the way that we do that is we put it in parentheses, and we say that we have negative infinity as the lowest we can go, comma, and then positive infinity as the highest we can go. So now what about our range? What can we put in for y? Well, for example, we could put in 2 for y, because if we have 2 here, that's 2 upwards, then we hit the graph, right? We get 2 numbers for x, actually. But unlike for the domain, unlike for x, there are actually numbers that we can't put in. You'll notice that if we put in anything in this area of the graph, we're never going to hit the graph because the graph only exists from here and above. So what is the lowest number that we can put in for y? Well, the lowest that this graph goes is right here. And to get here, we have to start in the middle and go up 1 square. So we can't put in anything less than 1. It has to be 1 or higher. So we're going to write this the same way we did for the domain. We're going to put 1, which is the lowest we can go, and then comma, infinity, which is the highest we can go. We can go up any infinite number of squares. So we're actually not going to only put parentheses. We have to first ask ourselves, is exactly 1 part of the numbers we can put in? And in this case, yes, it is. If we put in exactly 1, then we will hit the graph. So whenever we can put in the exact number, then instead of a parenthesis, we're going to put in a bracket. But we're still going to put parentheses around the infinity because it's not a number. You can't actually put in infinity, right? So our range is 1 to infinity. And there are other ways to write domain and range too. Like, for example, you could just put that y is greater than or equal to 1. That's a pretty easy way to write the range. So it just depends on what your teacher or professor wants you to do. So make sure you check to see what format your teacher prefers. And with that, you are now over halfway done with the problems in this video. There's only 4 more. But this one is polynomial division, which can seem pretty tricky, but just follow it step by step and you'll understand. So just like tons of the things that we're doing in this video, there are multiple methods to dividing polynomials. The first one is long division, which works every time, but it's long. And then there's synthetic division, which is a lot faster, but only works if this is x plus a number or x minus a number. Now, technically, we could use synthetic division here if we divided everything in this problem by 2, but if this isn't already x plus something or x minus something, we can always just use long division. So even though long division gets kind of confusing and there's a lot to keep track of, it's actually pretty much the same as the long division you did in elementary school with regular numbers. So the first part of our division problem, the big part, is what we're going to put inside of our little box. So we're going to write 2x to the third plus 5x squared minus 11x plus 6. And we're going to put this inside our little division box, or whatever you would call this. And then the thing that we're dividing by, 2x minus 1, we're going to put on the outside. And now we just need to follow the same steps as elementary school long division, which are divide, multiply, subtract, and then bring down. And in the wise words of my 4th grade teacher, you can remember this as, does McDonald's sell burgers? Or she actually said cheeseburgers because there was the step of C, which was to check your answer. But I guess you don't have to do that. So the first step is to divide. We're going to take the first parts of both parts and we're going to divide them. So we're going to divide 2x to the third by 2x. So we'll divide the numbers first, then the letters. So 2 divided by 2 is 1. We don't have to write the 1 because that's just not going to be necessary. And then we have x to the third divided by x. When you have x to the third and you divide out one of the letters, you're basically just subtracting it. So we had 3, we're dividing out 1, so we're only going to have 2 left. So x squared. And now you can see why we didn't have to write the 1, because putting 1 in front of a letter doesn't do anything. So now that we've divided, we can go to the next step, which is multiply. So we need to multiply the entire thing that we're dividing by the answer that we just got. So 2x times x squared, well, the 2 times the invisible 1, 2 times 1 is 2. And then x times x squared, when you multiply two letters, you're basically just adding them together. So you're adding another x to the x squared, that makes x to the third. And then we multiply the minus 1 by the x squared. So anything times 1 is itself, so that's just going to be x squared. But we do have a minus sign, so the minus sign stays. And you'll see that I've been lining these up with the numbers that are above it. And that's because we're now going to do the third step, which is to subtract. So we need to subtract these two parts here. But if we were to just add these together, that would be adding. So to make it subtraction, we just have to change all the signs at the bottom. So this becomes a minus and this becomes a plus. And now we just add these together. So 2x to the third minus 2x to the third, those are just canceling each other out, so those don't do anything. And then 5x squared plus another x squared. This would be just like if you were combining like terms, 5x squared plus 1x squared is going to make 6x squared. And now finally we can just do b, which is bring down. So we bring down the next part, which is minus 11x, just like if you were bringing down a digit in long division. And we're going to go ahead and repeat the process. So we need to do divide. Divide 6x squared by 2x, the first parts only. So 6 divided by 2 is 3. And x squared divided by x, you had 2 x's, and then you remove 1, you just have 1. And then we're going to put a plus sign in between all of these. Then we have multiply, so we're going to multiply the 3x that we just got to this whole thing here, 2x minus 1. So 3x times 2x, 3 times 2 is 6, and x times x is x squared. And then we have 3x times minus 1, anything times 1 is itself, so that's 3x, and we have a minus sign, so the minus sign stays. And now we can subtract. So we change all the signs at the bottom and we add them together. So 6x squared minus 6x squared, those cancel, those don't do anything. And then minus 11x plus 3x. So we're down 11, we got 3 back, but we're still down 8. So minus 8x. And now we can bring down this final part, which is the plus 6, and do it one more time. So divide. Minus 8x divided by 2x. 8 divided by 2 is 4. And we have x divided by x, those cancel out, and we do have one minus sign here this time, so the minus sign is going to stay. Then we multiply the minus 4, remember the minus sign stays, by 2x minus 1. So 4 times 2 is 8, and the x stays, and we have one minus sign, so the minus sign stays as well. And then negative 4 times negative 1. 4 times 1 is 4. And we have 2 minus signs. 2 minuses make a positive, so we have positive 4. Then we subtract, so we change all the signs at the bottom, so this becomes a plus, and then this is going to become a minus, and we add them together. So minus 8x plus 8x, those cancel, and then 6 minus 4 is 2. So what we have at the top here is our final answer, if the bottom part here that we end with is 0. But this isn't 0, it's 2. So that means we're going to have a remainder. And to do a remainder, all you have to do is attach the remainder to the end, and you have to make it a fraction. You have to put it over what we divided by, which is 2x minus 1. And that's all you have to do with the remainder. So this is our final answer here to this division problem. X squared plus 3x minus 4 plus our remainder here, 2 over 2x minus 1. All right, let's get into some functions, or f of x. And we have an f of x and a g of x here, and we need to find fog of x? Well, this is a composite function, and this reads f of g of x. And we can actually rewrite this as f of with g of x inside. If this was g composite f, or GOF, then it would be g of x with f of x inside. So remember that when you're solving a function, like for example, if you had f of 3, then you just replace x with 3, with whatever's inside the parentheses. So this would become 3 times 3 minus 2. So we're just going to be doing the same thing, except with an entire function, which is g of x. So we need to take f of x, which is 3x minus 2, but replace x with g of x, which is x squared plus 1. So we're going to rewrite this, but with g of x as x. So we're going to have 3, and instead of x, we're going to write g, which is x squared plus 1. So we're going to put that in parentheses, and then minus 2, that stays the same. And now we just need to simplify this down. So we can use our favorite pattern in algebra, the distributive property. So this 3 needs to be multiplied to both parts of the parentheses. So 3 times x squared, you can't multiply a number and a letter, so it's just going to stay as 3x squared. And then 3 times 1 is 3. And then this minus 2 is still hanging out here, so that's going to stay the same. And now we can simplify this even further. We have a 3 and a minus 2. Those are both just numbers, so we can combine those. So 3 minus 2 is 1. And there's nothing else we can simplify, so there we go. We've already found f composite g of x. It's 3x squared plus 1. All right, 2 more problems. For this one, we need to solve for x again, but this one we have a cube root in it. Now, a cube root is basically the same thing as a square root, except that a square root does the opposite of squaring, but a cube root does the opposite of cubing, which is putting something to the power of 3. And you can put any number you want here. You could put a 4 here, and then it would be the opposite of putting something to the power of 4, or whatever number you want here. So this cube root is kind of just this big clump of math that we can't do anything with yet, but we can get rid of this plus 3 first. So we can get rid of this plus 3 by doing the opposite of plus, which is minus. So we'll subtract 3 from both sides. And remember, you have to do it to both sides of the equation. So these cancel, and on this left side, we have our big clump of math. And on the other side, we're going to have 5 minus 3, which is 2. And now that the plus 3 is gone, we can do stuff with this big clump of math. So we have a cube root here. The opposite of cube rooting is cubing to the power of 3. So we're going to put everything to the power of 3, and we have to do the same thing to the other side as well. So the cube root and the power of 3 cancel. And on the left side, we have x squared plus 1. And on the other side, we have 2 to the third, which is 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So 2 to the third is 8. And now we just have a two-step algebra problem where we can get x by itself. So I'm going to get rid of this plus 1 first because it's less attached to the x. So the opposite of plus is minus. We'll subtract 1 from both sides. These cancel out, and we just have x over 2 is equal to 8 minus 1, which is 7. And now we just have one step. So remember that a fraction just means division. So the opposite of division is multiplication. So we'll multiply both sides by 2. The 2's cancel out. And on the left side, we just have x. And on the other side, we have 7 times 2, which is 14. So our final answer is x is equal to 14. And as always, you can plug in 14 back into x and see if it makes the equation true. That's how you can check to make sure your answer is correct. All right, here's the final problem of this video, and it's a logarithm problem. So I know that logarithms can seem a little scary, but there's actually 2 different ways that we can solve this. I'll show you the regular, just pencil and paper way, and then how you can put any log into a calculator. So what is a log? Well, a log is basically like the opposite of an exponent, sort of. The answer to a log is some sort of exponent here. And the exponent is going to be what we need to put on the small number to get the big number. So in other words, to find this log, we have the small number 3, and we need to figure out what exponent we need to put to make it the big number, which is 243. So what exponent do we need to put here? Well, we can basically just do trial and error for this, right? So remember that exponents just mean multiplying over and over until we get a number. So let's just start multiplying by 3s. 3 times 3 is 9, times another 3 is 27, times another 3 is 81, and you can put this in your calculator to make sure. And then times another 3, if you put this in your calculator, you'll get 243, which is the number we're looking for. But to get to 243, we had to multiply 3 5 times, which means the exponent here is going to be 5. So our final answer is that the log base 3, that's how you say it, it's the base, the log base 3 of 243 is 5. And that's our final answer. Now, what if you didn't know that? What if you weren't sure how to find the log? Or what if the log was decimals or fractions? Then there's no way you would have just trial and errored it, right? Now, your calculator probably does have a log button if it's a scientific calculator. And you'll notice that it asks for you to find the log of some number. So like the log of 50. But what does that even mean, right? We don't have a base to go off of. But whenever you don't have a base for a log, that means that it's base 10. But that's all your calculator lets you do. It only lets you do base 10. But there's actually a way that you can put in any log into a calculator. All you have to do is find the log of the big number, ignore the small number. So in our calculator, we would put log of 243. But then we have to divide it by the log of our small number. So we divide it by the log of 3. And if you were to put in log of 243 divided by log of 3 in your calculator, you should get exactly 5, which is what we found before. So this is how you can find any log on a calculator. So there you go. Those were 45 different example problems. But there is just one issue, and that is that I wanted the title of this video to say over 3 hours. And right now we're at 2 hours and 58 minutes. So I guess that means I'm just going to have to give you a bonus problem.
Wow, that's crazy. That's insane.
So here's the bonus problem. We have to solve for x here, but there's like a bajillion logarithms. So x, in case you can't see it, is right here. It's trapped inside of a logarithm, but there's also another logarithm, but there's a 2 on it. So how do we solve for x? Well, our ideal scenario is if we just had one log on either side that had the same base. So for example, if we had log base 3 of x plus 3 equals log base 3 of 8, then because these logs are the same, the insides also need to be the same. So we can just ignore the logs and just set x plus 3 equal to 8. So that is our ideal scenario, but how do we get there? Well, I think that because we have two different logs here and they're being added together, we need to try to combine those two logs. And we are able to do that because they have the same base. All of the logs here have the same base. The only issue with adding these two logs together, though, is that there's a 2 in front of this log. So we need to get rid of this 2 so that we can add the logs together and then cancel out the logs. So let's start with this 2. This right here is multiplication because there's no sign in between. So it's multiplying 2 times the log. And there's a rule for logarithms that says that if you're multiplying the log by a number, then you can move that number to an exponent on the inside of the log. So 2 times the log base 3 of 2 is the same thing as if we just put an exponent of 2 on the big number. And then that would erase this 2. So this is going to be the same as just the log base 3 of 2 squared. That's 2 times itself. 2 times 2 is 4. So 2 times log base 3 of 2 is the same as the log base 3 of 4. Now we haven't touched the rest of the equation, so it's just going to stay the same. And now we can work on adding these two logs together. So whenever you're adding together two logs that have the same base, the same small number, then you can multiply the insides and combine the logs. So these are going to combine into one log that still has a base of 3, but the inside is going to be 4 times x plus 3. And to me, this looks like it's going to be the distributive property. So we have 4 times x plus 3. And using the distributive property, we have to multiply the 4 out to the x and to the 3. So 4 times x, you can't multiply a number and a letter, so it's just going to stay as 4 times x plus 4 times 3, which is 12. So the log base 3 of 4 plus the log base 3 of x plus 3 is the same as the log base 3 of 4x plus 12. That's just 4 and x plus 3 being multiplied together. And now we haven't touched the right side of this equation, so it's going to stay as log base 3 of 8. So now remember what I said about having one log on each side, and as long as the bases are the same, that tells you that the insides will also need to be the same for these to be equal to each other. So because the insides of the logs have to be the same, we can just ignore the log part and just take the insides and equal them to each other. So 4x plus 12 has to be equal to 8. And now we just have a two-step algebra problem to solve for x. So I like to get rid of addition and subtraction first. So this is being added. Let's subtract 12 from both sides. So these cancel out. On the left side, we just have 4x. And on the right side, we have 8 minus 12. Think of it as money. So you earned $8 and then you lost $12. So you're down $4. And now we just have a one-step problem that I'm going to move up here because we're running out of room. So this right here is multiplication. I'm going to do the opposite of multiplication, which is division, and divide both sides by 4. So these cancel out. On the left side, we just have x. And on the right side, we have 4 divided by 4, which is 1. And we have 1 minus sign, so the minus sign stays. So our final answer for solving for x is that x is equal to -1. All right, there we go. I can now officially say that this was over 3 hours of Algebra 2 final exam review. Now, in these videos, I've tried my best to go over all of the most important concepts, but maybe you know better than me. Maybe there's something that I didn't talk about in this video that you know is going to be on your test, and you're like, why didn't you talk about this? Or why didn't you talk about that? Well, lucky for you, I have a video that's even longer than this. It's over 10 hours, and it goes over basically every algebra lesson. So if you want to look for something specific in there that you want to know about, then this is the video you want to watch. And as always, if you have any questions about this video, go ahead and leave it in the comments, and I'll be sure to answer your question. Thanks for watching, and good luck on your algebra final exam.